Okay, for whoever's watching the recording, this is Intro to PLCs class, and it is May the 28th, and we've got some. I've already in progress helping one student write some logic. So you just jump right on in, and again, if you're watching the recording, you can contact me in between classes for help if you need it. So don't hesitate to shoot me an email or call if you need to, if it's an emergency. But I do check emails. I hear emails on my phone when they come in. So email is a preferred method. If you want to talk, then you can call my phone, be fine. So anyway. Okay, so Benjamin, you can go ahead and do your screen share again if you want to.
Okay.
So you want to hit the triangle to the left of your main routine. And then double click main routine. That'll open it up. So you want to start writing your logic in there on rung number 0. And you're going to use the addresses of the real addresses that I had given everybody.
Mm-hmm.
And let me pull that up. You can cut your screen share off just for a second. I'm gonna turn mine on. I need to pull up the wiring diagram there. So let me hit there and go down. Okay, can y'all see the input addresses there on my screen?
Yes, sir.
All right. Hold on. What? Hold on. I heard my mother say something. Let me go check on her. Hold on. What is it? What message? Okay. What? Yeah. She was telling me there's a tornado warning.
Yeah, it was for Turkey.
But anyway, Benjamin, you see the 3 limit switches there, and the real input address is the local 1. And the 1 means slot number 1. It's the first position in the PLC. If you look on my webcam where I'm pointing there, this is slot number 1, and slot number 2. All of the inputs that we're using is in slot 1. And the outputs that we're using, well, the inputs are DC, 24-volt DC. There's also some outputs in slot 1, but they're DC outputs, and I'm not going to use DC outputs. I'm using AC outputs. So I added another module over here in slot 2. This module is a relay output that you can use it for AC or DC outputs. So this is slot 2 for outputs and slot 1 for inputs. Okay. Now, so the inputs that you see for the limit switches is local, slot 1, I means input, and data 3 means it's the third input in slot 1. So like if I hit input 3, you see that light coming on up here, where my finger is, way up top there. When I hit that, you see that light come on there. So I go on, off. See where I'm pointing?
Mm-hmm.
Yes,
So,
sir.
Yeah, I'm making a simulated limit switch come on, and you see that LED come on like that. So that's the physical input, and then the limit switch 2 is going to be input 4, and limit switch 3 is actually input 5. So don't get confused by the limit switch numbers and the physical inputs, because I started with input 0 for the stop button, normally closed, that we use for memory logic, and then the start push button is input 1. Input 2 is reserved for another lab that's going to have a 3-position switch that will be sharing 2 inputs on a 3-position switch for the next lab after this. So I have input 3, 4, 5 for your limit switches. Okay. And then the output is in slot 2, and it's going to be local slot 2. 00 means output, data 0 means it's output 0 in slot 2. And that's your master control relay coil there. And the A1, A2 are the terminals that you tie to physically on the reel down here where I'm pointing down at the bottom of the screen. This is your MCR master control relay here. And those 2 terminals are A1 and A2 that I'm pointing out way down here at the bottom of my webcam. Okay. So that's the output address, and then there goes your 3 input addresses for this. So if I go back to well, you can go ahead and do your screen share if you want to. Wait, I'm gonna hit stop. And well, good evening, everybody. I'm gonna check you off that you're here. So you got Bill and Ivy. Eric Martin. Jamie Jones. Connor Fairclough.
Yeah.
Connor, is Cameron with you?
Yeah, I'm here.
Okay. How y'all doing?
Doing good. How are you doing?
Doing pretty good, man. I'm hanging, man. One day at a time.
It's wet today. It's been raining.
Did what now?
I just said it's been rather wet today.
Yep.
Oh, yeah, I know. I'm
Got
stoked
Roger.
right now. Well, I had a little bit of time to dry off.
Did you work with
Yeah, I
Andy?
couldn't find time to do that homework I want to try to get done today.
Okay, you got to tighten up there,
Yeah,
Roger.
all week.
You're making too much money. You need to be doing your homework.
Yeah.
I'm just kidding.
No, I'm probably gonna start like taking a day in the middle of the week off so I can catch them up on homework then.
Uh-huh. Or just do it while you're resting. That's what they used to tell me at work. One guy say, "How about getting this here done while you're resting? How about doing so and so while you're
I'll tell you
resting?"
this way.
I'm just kidding, man.
I'll put it to you this way. I get home and then by something, it's time to go to bed and wake up before the next morning.
Yep.
Yeah.
Hey, one thing I forgot to tell Roger, for you and Connor and Cameron, anybody that's got an internet connection that's kind of spotty, if it's a little spotty,
Mm-hmm.
do you have unlimited data on your cell phone? Yeah, I'm asking, on your cell phone, do you
No.
have an unlimited data plan?
Nope.
You don't?
No, we don't.
I got prepaid.
Okay, because Benjamin, one of the guys that's in here now, he's got unlimited data, and what he does is he goes in his phone, and in his phone he turns it into a hotspot, mobile hotspot. So he enables his cell phone to be a mobile hotspot for his laptop, and then he cuts the Wi-Fi off, and he's using the data because he's got unlimited on the cell phone, and he's getting good signal through the cell phone. The laptop's actually using the cell phone signal, but he's using his data, not Wi-Fi. But he has unlimited data, therefore it's not costing him anything. So that's what he's doing because he doesn't have good internet at his house, and it works surprisingly well. So that's kind of an option there too. If it didn't cost you much to get unlimited.
I'm lucky to have my phone right now because you won't.
Because what?
Well, yesterday I lost my phone. I lost my phone yesterday, but I knew exactly where it was. I was sitting there doing a plug in a bathroom, and I set it up there for a light because I left mine at the house, and it fell in the crack there. And I was like, I can't get out now. I get out in the day, and it's in a little sealed off area where the only spot to get to it was through the top. And so throughout the day, evidently the people come in and put the granite countertops on it. And so my phone was stuck in there last night, but thankfully, I think it was the builder or somebody. He went in there and removed it. Evidently, it was the wrong kind of countertops anyways. So,
good gosh,
I was very thankful for that.
Yep.
Yeah.
Yeah, I would be too. Man, that's crazy sounding.
Yeah. They already painted the walls too, and so it won't like we just break that. I haven't got anything.
Okay.
Looks like everything's starting open.
I was just checking my messages there. So here's where we are, fellas. I need to see. Let me name off the people that I need to actually see your emulator function, and it would be Darren Branch, Cameron, Michelle, Dylan Ivy, Jamie, and Justin Sessoms and Dylan Shook. So if you're in the group and you have your emulator program done.
I'm ready, Mr. Durwood.
Okay. Now hold on before you get it ready, and Benjamin, pull your screen up one more time and let me get you started. We got a loud alert here.
Yeah.
Flash flood warning until 9:15. Avoid flooded areas. Okay.
Look mighty dry outside to me. As if I was in the washing machine. All right. Go ahead.
Okay. So Benjamin.
Sure.
On your first one, go up top and get an examine on instruction. Well, wait a minute. Hold on. Before you start any of that, you have to add slot 2 module. If you look in the webcam where I'm pointing here, it's slot 2.
Mm-hmm.
You have to add that module in your expansion IO. So go down in your controller organizer on the left, down to where it says you want to scroll down. Go to the left side of your screen.
So, Mr. Durwood, what exactly is the expansion IO?
Expansion IO is when you're adding. If you look at my webcam here.
All right.
Input, output.
This is the basic PLC itself that has 16 DC inputs and 16 outputs that are embedded inside, okay,
Uh-huh.
with the CPU. So
Okay,
this
so that
has,
gives you like a visual effect, pretty much.
what you do is you take this end cover and you slide that off, and you start adding more modules to it, and then you take that end cap and put it on the last one in the rack. So everything in addition to this slot one here, when
Uh-huh.
you start adding things to it like this one, that relay output, this is slot 2. And then if we join this, I've got it separated over here, but that will be slot 3, 4, and 5.
Okay.
So expansion I/O is everything that's beyond the embedded I/O that's in here.
Okay, I got you.
Yep.
Okay.
And they also call whatever's embedded, they call it fixed I/O, because you can't change it. If you get some of the inputs and outputs in here that go bad, you can't fix them. You got to replace the whole thing. So it's all one unit called fixed I/O. And you get
Okay, I got
anyway, that's the, okay. All right. So we're going to get you started here, Benjamin, on doing real I/O, and then I've got to back up and see other folks that haven't showed me their emulator yet. So go down to where it says expansion I/O and right click it and hit new module. And now you can scroll down in the list and you can find the part number that I gave you on the diagram, the new one I sent you. If you look on that paper, it's going to tell you, like right in here, right in there, it's going to tell you the part number for that add-on module.
Going to be 1769 OW16.
That's right. And also, one thing I forgot to put in there, I'm going to add it. I'm going to pencil it in red on this paper, and you make a note that the firmware revision of it is a 3.1, and that's important. So let me jot that down.
You said OW
16.
Yeah, if you give me a second, I'll pull out a box for the new module and let you see. So when you're at that point right there, you want to give the module a name. You can just say relay output. It would be a good enough name. But I've got in front of the webcam, I have the actual box that one of these modules come in. So when you go into the box like that, there goes a module that's wrapped up in an anti-static bag. And what I can do, I'll actually pull it out again because some of y'all didn't make it the other day. So this is a brand new module I'm pulling out here. And it tells you here in the yellow that it says attention, static sensitive devices, if you can read that. You may or may not be able to read that. And can you see where it says attention, static sensitive devices?
Yeah, I see it.
Yes, sir.
Okay. This is a metallic looking bag. It's actually conductive. It's a conductive plastic bag. So it doesn't allow static electricity to build up. So before you open it up, you're best off to put a wrist strap on you and ground yourself to bleed off static electricity, or at least touch a grounded object and bleed off any static that might be on you that you may pick up walking across carpet or something. But this module here it tells you that it's a 1769 OW16. Can you see that?
Yes, sir.
Series A, it's a Series A, and then the FW revision, firmware revision, it's a what? Can you read that?
3.1.
That's right. So you want to write this information down, add that to your paper that I sent you. I'll have to add that to it and put it in Moodle, but it's a Series A firmware FW revision 3.1. That information has to be put in the module properties right now as you add this module to your project. So that's an important thing there. And by the way, you don't ever want to be touching the metal pins in here, because if you do and you got static on you, you could actually damage the circuitry that's inside there, the electronics. You could damage it because static electricity can be hundreds or thousands of volts, you know, and it could actually damage what's in there. Also on the outside of the box, it tells you firmware revision 1 Series A, if you see right there. Can y'all read that?
Yes, sir.
Gives you the part number, and it gives you firmware and series. So that, if you got the cardboard box, you're still good to go. You don't really have to pull the module out to see that. Okay. So go in there and change the module definition. You hit the change button. Right now, it's actually revision 1.001, but you've got to change it to a 3.1. So just change your revision number to 3.1. And on keying, y'all, for those of you that weren't here on Tuesday, electronic keying is this. Keying does, it makes sure that you cannot plug in the wrong kind of module in that slot that I'm pointing at. So if you had to replace that module, and this one went bad, you got to put a new one in. If you set up your properties right in the program and you put the wrong kind of module in here, that PLC will not accept it, and it's not going to try to run with the wrong module in there. So keying means making sure that whatever you put in slot 2 is going to be compatible with what you originally put in there. So your options are this. If you do the drop down on compatible, now you can have an exact match. Now what that means is it has to be the same firmware revision. It's got to be an exact match in every way. I would not do that. I would say compatible module, which would mean that if it happens to be a different firmware revision, but it's actually compatible, then it would accept it, because you could have, you may have a newer firmware coming in that comes into your plant, and that may be compatible with the previous, if you know what I mean. And then disable keying, if you hit disable, that's a no-no, because then it'll take anything you put in that slot. So then if somebody puts the wrong module altogether into there, it'll accept it, and you could have a really dangerous situation. So keying is something that's coming up, I think maybe chapter 3 that we talk about. There used to be physical keying, that wherever you plug the modules in, behind it there would be a plastic key bands behind it that would not let you actually physically even plug the wrong one in there physically. And but they got away from the physical keys behind it, and they have electronic keys. So that's good, and hit OK. If you have any questions about any of this, just say the word, and we can always stop and discuss anything that we're doing. Also, make sure that you're in the right slot, because it's assuming you're going to be in slot 2. That's the first one that's available. So 2 is the correct one. And that's it. You hit OK. And now you can hit close, because it just takes you one step out. So hit close. And now if you notice over on the left side of your screen, under expansion IO, it shows that module. You see it?
Yes, sir.
So now you can actually create outputs because it knows what you have. So now you go up to your contacts and choose an examine on. Okay. And now, yeah, when you do new tag now, you put your name in there for the tag. It'll be your safety gate 1 limit switch, or gate 1 limit switch if you want to keep it short. You can say LS for limit switch and make it even shorter. Gate LS, your gate 1
L
LS.
what? Okay.
LS for limit switch, yeah. And now listen, don't hit create. You don't want to. You didn't want to do that. Go ahead and go back and double click on that. Hold on. You need to hit the undo. Go up top and hit undo. Right, pull. Yeah, start that again. Yeah, new tag.
What do we have the name under?
No, yeah, no, the name is fine, but don't hit create though, because you're not done. You're not done with it yet. So you can go ahead and give it.
Controller switch, right?
Well, it's still going to be a gate, gate 1 limit switch.
Oh, okay.
Yeah, that your name was fine, but you had to make it a different kind of tag than what you've been doing. And you want to put like put a number in there like 1, like gate switch 1, or limit switch 1. Now, listen. If you look down there under type of tag, it says base. Now, base tags are just tags that are internal to the PLC, not real world. So this is not going to be a base tag. It's going to be an alias tag this time. Alias. So hit alias. And alias is like if you know someone, his name is John, but he's an alias for some other name. Okay. It's the same person, but they have an alias name and then they have a regular name, right? So it's the same person. The gate switch 1 limit switch is going to be the alias name for a physical address. So you want to go under local 1I and hit the triangle to the left. No. Hold on. That's it. Expand that. And now go under data, go to the right of data and click it. Between data and INT, go to the left of that and click it. And now it shows you have 16 inputs to choose from. So which one are you going to use?
I guess 1.
No, you want to go to that diagram. Look, let me put the diagram in front of the camera. Which one are we going to use for the limit switch?
Looks kind of blurry.
Can you read that? Hold on.
It should be data 3.
Look, let me pull up the one on the screen that you can see, or can you see that now in the camera? Is it blurry?
Yeah, just kind of blurry.
I can't see anything.
How about now?
It's 0.
Can you actually
for 1.
Stop
Can you-
for a
can-
limit
can you
switch.
read
it?
That means the stop
Anything.
button.
huh? Can you read the addresses for the limit switches?
Oh, there it is.
Okay, Benjamin, can you make that out?
Yeah. It's 3.
It's 3. So you're going to use 3, 4, and 5.
Is it the same worksheet that's online?
It's the
Yeah.
same one. It's the same one. Yeah, it's the same one.
He emailed it to us too.
Okay.
I emailed it to you this afternoon, and I put it in Moodle last night. So you'll click 3.
Yeah.
and now hit create. So you've created an alias tag for a physical input and hit create. You see it show up there now. Now that's a real input. That's a physical input with an alias name. So you can continue to do that. You can continue to do that. And when you go to do your output, if you want to go ahead and do your output, and then you come back and finish the inputs, the output's going to be slot 2. Well, let's just see how you do. You can kind of try it on your own. Once you get limit switch 2 and 3 in there, then put your output in there. And it's going to be the MCR. If I put this on the webcam, look up here. You see your MCR relay. So it's going to be output 0 in slot 2. Can you see that on the in the webcam? Just refer to what I sent you. You can open that up on your computer to look at it to see it clear. Because while you're doing a screen share, I can't do a screen share while you're doing one. But I've got my webcam there. So anyway, this is the same paper that I sent you. And let me update, put the series A in firmware 3.1. Now in the red I just added there for the module, I put on there series A and firmware revision 3.1. So you can add that to your paper. If you print it. If you print that, now you won't be able to add it to the electronic version because it's a PDF. So just make you a note of that. Okay. So yeah, now this is just going to be gate. It's going to be gate number 2 limit switch.
So, Mr. Durwood, does he need to be entering this stuff into the expansion or the embedded?
Embedded. For
Okay.
the inputs are embedded, and then the output is expansion.
Okay, I was making sure because it looks like he's on expansion right now.
Well, look, what determines that is when it says alias for what? When he does the alias part, that's what determines what that tag's going to be attached to.
Okay, got
So
you.
if you watch him, now go under where it says type and make it alias.
So that'd be like the local 2 would be the second one.
No, for the second limit switch, you make it an alias.
No, I wasn't talking about that.
For the output, it'll be local 2 for the
Yeah.
output. Is that what you
Yeah,
mean?
that's what I was asking.
Yeah, that's exactly
So all
right.
yeah, so all the outputs are going to be the second. Okay.
We'll be
So
slot 2.
for all the outputs, do you just go? Okay, gotcha.
It will be local 2.0. Yeah, for output.
Okay.
So Benjamin, now go down to local 1I and expand that with a little triangle. And go beside data and open that up. Local 1I data. You've got to go down where it says data, local 1I data, beside data, and click in the blank area. Now open that up and now choose what's going to be the input address for that one.
1.
No.
4.
You got to go by the drawing here. Look, you got to go by the wiring here. You got to go by this. You see it? Can you see it in the camera?
Yes.
You got to go. That's why I sent you the drawing. You got to go specifically by that. Yeah. So that's our plan. You got to go by a drawing, a input output wiring drawing. Okay.
Can you say that again? Just so I know what it looks like. I was still looking for it.
The paper,
Internet's being a little bit slow. Yeah.
and the way you'll know if it's the new one is I have terminal numbers on the coils and all. I've got terminal numbers on them. I added that stuff last night. Did it on the real starters that I have down here. I put real terminal
Okay,
numbers.
yeah.
Yep. It's in your email. You can get it off your email, and you can save the PDF to your phone. I would you really need to be saving
My email
them.
finally loaded.
Okay. So Benjamin, you've got
Well, I
that.
don't advise saving it to my phone.
So you can go ahead and hit create now. I can tell our internet is kind of, with the storm, it's kind of a little, we're going to kind of bear with it tonight.
Yeah, you sound like you talk to a fan every time you talk.
I sound like I'm talking through a fan.
Take the parrot.
All right, something
Yeah, most
went
of the
wrong.
time,
I don't
that
see,
and
Benjamin,
and
I don't,
also
Benjamin, do you see your contact come up, your second one? I think
Not
it,
sure.
did your second one show up? Because I don't see it.
It's all the way to this end.
Wait a minute. Hold on a minute. I'm sorry. You put an input address on the output coil. I didn't realize what you were doing there. And I had actually told you to do the output. So in that case there, we got to change it since you've got an output instruction. Let's go ahead and let you do, you got to create a new tag for the output for the master control relay. I didn't realize that you had actually clicked the output instruction. So we've got to put the correct address there for that. So it's one that, you got to create one. So you got to do some, hit some, click over there, click on your output, click one time, and now hit undo. But back up a few steps to get rid of what you, of your now. So if you're going to do the output first and then back up and do the inputs, you choose that. And now on that one, it's going to be, okay, yeah, you're good. It's going to be MCR relay. And you can put the word coil in there because it's the coil that you're doing here. And it's going to be an alias. You got to go under type and hit alias and say that this is an alias tag. And now go down to slot 2. Output. It'll be local 2O, and expand that to the left with the triangle, and scroll down. And now under data, click to the right of data, and you'll have some options. Right now, which output's it going to be? I got the paper in the webcam.
Zero.
well, it's the same thing I was looking at, but
Output 0.
it downloaded.
So it's output 0 for the MCR relay. That's right. Create. That's correct. And now go back over and click on limit switch 1. Now that's where the cursor is now. Now you can go ahead and add 2 more XIC, 2 more examine on contacts, and create limit switch 2 and 3. All right. Those of you that I haven't seen your emulator, as soon as he finishes this one line, then I'm going to have him cut his screen share off, and he can continue doing all 7 logic functions there while I'm watching I got to see your emulators, and we get everybody caught up.
Durwood, we're
Yes, sir.
using the inputs and like in sequential order, like
You'd be under data,
1,
right?
2, 3, 4, 5, 6, 7, or we're just using them in order.
Yeah, they're in order, but you need to go off of the drawing to see how I've got them set. We're not going to change that part. Go off of the
Okay.
drawing to see which ones are for what. Because that's the way I've got it
You
wired.
say drawing, but
You go by the drawing. Go specifically
yeah.
by that drawing. Yeah.
That looks good, Mr. Durwood.
Yep. Oh yeah. Right. What you're learning right now is the school had to pay $1,350 for me to go to school for 4 days to do what you're doing now. $1,350 per week, and I went to 3 different levels on this stuff. I got level 1, 2, and 3. So it's $1,350 a week per person to take the class, plus hotel and food and all that stuff. So it's pretty expensive, but you're getting it right good bit cheaper. So now, you're doing good there, Benjamin. So on the next line, when you do the ORs and you do the parallels, use the same addresses as far as the switches there. But on the output, you got to choose the next output. You can't use the same output. So you're going to have to advance it up to output 1 for motor starter 1. You can share inputs, but you can't share outputs. And then the next line of logic would use the next output, which would be output 2, and so on. But I wanted you to use, if you look on the picture here, I wanted you to reserve the light, the green and the yellow and the red lights, those last ones, reserve the last 3 outputs for your for NOT logic, NOR logic, and NAND logic. So the NOT, the NOR, and the NAND will be for the light bulbs that are here, which will be the last 3 outputs. And your other circuits, like for output 0, it will be and then output 1 would be for the OR, and then output 2 would be for combination and OR, and then output 3 for that starter would be for memory logic. So that third starter there will be for memory logic, which is the 7th logic function. Okay. And
okay, yeah. That's what I was asking about.
Yep. So I prefer to have your lights over here, to have those on NOT, NOR, and NAND, to do it that way on lights instead of starters. Okay. So Benjamin, if you want to, I think you're rolling pretty good there. You can cut your screen share off, and I'm going to start looking at the emulator for other people. Okay. And I'll start at the top of the list that I see up here with Dylan Ivey. And if you want to do a screen share, let me watch the emulator run. Okay, let me move my screens there.
Tell me when you're ready.
Okay, if you'll just toggle one of your safety gates off on that first line. Okay, that's good. I see that. And toggle one of those on. That's good. That's fine. You can move on down to, you do one of those. Good. All right, move on down. Toggle, and that's going to be, that one is going to be for your refrigerator door there. So
Yes, sir.
that's for the refrigerator door. If you close the door, it actually shuts that switch off, and then it shuts your light off that's inside the refrigerator, or a trunk lid on a car. So that's your trunk light or your refrigerator light. Okay, next one, just hit one of those. So if you trigger one of those, then you're going to lose the fan. Okay, so those could be like thermostats or you just, or whatever kind of application you could think of. And then your NAND logic with the parallel, that's going to be for your vehicle, for your passenger door and your driver door. So you have to actually trigger both door switches by closing those doors to make that interior light go off, just like on any vehicle. So that's good. And right, you trigger the start button, toggle on, toggle off. And that's memory logic. So it remembered that holding contact, it remembered that you hit it. And now you can toggle the stop button, and it's going to break the circuit. Right, and then that now release the stop button by retoggling the stop button to put it back in the original state that it was in.
All right, you good?
Toggle your stop button back to where it's like original. Right. So everybody noticed that when you hit the stop and then you lose your starter coil, and then you release the stop button goes right back to closed again, but yet the starter doesn't come on because you've got to initiate that start button again. Okay. So you're fine there. That's all good. Let me check you off there, and we'll see who's next. Now, by the way, if any of you that are online now, if you have not completed the basic logic questions, there is a basic logic lab that explains all of these circuits, and there are questions at the end of that written lab. So I haven't checked today to see who has done it and who hasn't, but if you haven't done the questions, go in Moodle and you click on the basic logic lab, and after all of the explanations, you go in there and fill the blanks in it and put it in your own words, and submit it. So I wanted to get those graded this week, and I haven't graded anything so far as far as that goes, but I've got to get started on it tomorrow. And so is everybody aware of that paper being in Moodle?
Yeah, we are.
Okay,
Yes.
and all of you may have done it. I'm not sure who has and who hasn't because I haven't checked it this afternoon. I was going to get into it, and then another student was actually trying to download their software today. They had not even downloaded their studio yet. So we got two guys that are trying to download software right now. So they got some catching up to do, but I hope they'll make it. So. All right, so see, I think I've already saw Rogers. How about Connor? See yours?
You saw Connor's, but you haven't saw mine. I can show you.
Cameron, yeah.
Yeah.
I meant to say Cameron.
Oh, that's good.
But all I'm seeing showing up on my end, I'm seeing the name Connor show up.
Yeah, you don't see my name come up.
Because he logged in.
Yeah, we're logged up. Alrighty. I believe it's in run mode, I think. Hello?
Hello?
Oh, hey, yes. You want me to go ahead and toggle these?
And also there's some hotkeys, Control T, if you see that. You see where it says Control T?
Yeah, I see that.
If you highlight and hit Control T, then that's a set of hotkeys you can do it with.
Okay.
Okay, that's fine. One of those is fine. I know the rest of them will. And then you do an and. That's perfect. And we know that the door switch 2 will. Now close the refrigerator door. Perfect. Light went out. And now toggle one of those. Perfect. Okay. And now this is your driver door and your passenger door.
That door would be
Right. You close the door and the
right
light
now,
still.
now the door's closed.
Yeah, the door's closed, but it's still on because your passenger, your girlfriend, has not shut her door.
Yep.
Now. So that's good. Toggle. Starter come on, and now untoggle the start bit. Because you got to release it. Physically on the real thing, like in my webcam here, I'd hit that green button and then let go. And hitting and letting go takes you 2 steps. You got to toggle on, toggle off, you know. Right. Now that releases it. Yeah, that's good. And then you toggle and then untoggle the start button again. That you have to do 2 steps to where physically all I'm doing is one on a button.
Yeah.
That's it.
Yeah, it's got to release.
It has to release, yeah. And that's again, at least you can at least we have emulators to work with. That's a whole lot better than not having one at all. I don't feel so bad about the class now because you have that, you know. If you didn't have that, I would be feeling kind of bad about things. Let's see.
Yeah.
Okay. That's good. So if you want to, yeah, let's see who's next. Jamie, how about yours? Or let's see, yeah, Jamie Jones.
Can you hear me, Durwood?
Yeah.
I don't got mine done.
Okay.
I come home and done the Moodle worksheets last night and watched about 2 hours of your Tuesday night thing. But I'm probably gonna have to call you anyway. But I'm gonna get it done over the weekend.
Have you started? Do you want to start it and maybe let's get you jump started on it? Or
yeah, if you don't mind, that'd be fine with me.
I'd like to do that because you can catch up before we get off tonight, and I can see it as fast as you are.
You ready?
Yeah.
Yeah, we've been trying to put in taters, so now with all this rain, I'm gonna have some time off next 2 or 3 days.
Yeah.
All right. You see it?
Okay, so first line's good, second line's good, third's good. All right, so your next one's going to be not logic. So you'll go over there and click where it says end on the left of your line.
All right.
Right there. And now your next one is going to be an examine off instruction. It looks like normally closed.
Where at? I'm lost. Is last week?
It's above alarms.
Right there.
Right.
All right.
That's it. Wait a minute. You got to add a rung. We didn't add rung yet. So go where it says end in the blue, or you can choose it there. Either way.
Okay. So add a rung.
Yeah, you've actually added 2, but it's okay because you're going to need them anyway.
Okay.
So go to rung 3, click it, and now you can get your examine off instruction. That looks, yeah, that's it. Yeah.
All right.
And you can call that the refrigerator door limit switch.
All right, and that's going to be a,
It'll be no, it's going to be a base tag because it's not a real physical input.
okay,
Base
So-
tags are internal to the PLC. They're not real world I/O.
okay, so create that.
Right. So everything with the emulator is going to be base tags,
Okay.
and then you'll choose output energize.
Durwood, where do you find the not gates, like the normally closed gates? Which ones are those?
You go above alarm, and it looks like normally closed on your toolbar in the center of the screen. Is that what you mean?
I know that, but I was talking about for the inputs. No, I was talking about for the inputs. I've got all the logic down. I was just going through and adding the tags a mess. I was just trying to remember that, but that was the only thing I couldn't think of.
I don't understand. I don't know what you're asking for.
I'm looking at the piece of paper. I see the 3 limit switches, the stop, the start, and then the outputs, but I don't see the normally closed gates.
It's not going to be
'Cause
normally
you need
closed.
those for not.
No, listen. For you,
Mhm.
you're going to use. Are you doing the emulator, or are you doing? No, you're not doing the emulator. You're doing the real PLC.
No. Yeah.
For the real
Yeah, that's what I was trying
PLC,
to figure out.
for the real PLC, just use input 3.
Input 3 for the.
Yeah, for what you're doing, use input 3 for that, and in the program, use an examine off instruction. But your physical device out here, it's a normally open. Okay. Now, in real life, it would not be. It would be. In real life, you would be doing it with a physical normally closed button and no PLC involved. Okay.
Okay, so it'd be local 1.I data 3 for the. That's what we'd use.
That's what you're going to be using for that.
Use the,
because I didn't wire up normally closed switches. Okay. But if you use what I'm using, if we're using that,
yeah,
you can simulate the exact thing of a refrigerator. If you put an examine off instruction in the program, but you use a normally open switch out here in real world to trigger that instruction, it's going to give you the same exact effect, because the physical device out here, the switch
just act in reverse, right?
It's reverse. So you would use the examine off instruction in the program, because the physical device out here in the real world is actually normally open that I'm using here. I didn't wire normally closed inputs. I didn't physically wire them. So you're going to have to make it that way in the program for it to function that way. And again, we're mimicking what a refrigerator door would do, and it would be a physical button that would be physically normally closed, but no PLC involved, with a refrigerator. It's just a physical switch, and you're just placing it in the program and doing the same thing. Yeah. Okay. Yeah, it's a good question. Yeah. Okay. So you can call that tag your refrigerator light, and it's an alias tag. No, it's an alias. Wait a minute. I'm sorry. You're in the emulator, so you're fine. Yeah. I'm zigzagging between the emulator and real, so you're good. That's fine. Yep. And then the next one is going to be the NOR, which would be 2 normally closed in series. Two examine offs in series. Right. Yeah. And you can just call that limit switch 1, limit switch 2, or you can say thermostat 1, thermostat 2, whatever you kind of want to call it, be okay. Yeah, once you get to rolling, Jamie, you'll be fine. You know, you'll be right up at the front like always.
Yeah, we just it's been a bad 2 weeks. All right, Durwood, what else you want to add?
Your output can be a fan, you know. But you need to give it a new name like fan 2 because you can't reuse the same output tag. Yeah, you hit new tag and you can say fan 2.
Can't get to it. There we go. I had y'all in the way. All right, new tag. Fan.
You can say fan 2. Or anything that's different from any other tags that you've had. It has to be a different.
Okay.
You can't repeat output tags.
No.
That's fine.
Yeah.
And you have to right click and hit add run.
Okay.
And now this will be the NAND logic with 2 normally closed in parallel. For examine off, yeah. Right, you have to highlight the rung number for it to know where to put it, yeah. No.
What is coming up on there?
Are you right clicking? You don't want to right click, you left click. Yeah.
Okay, there we go.
Right.
And you want 2 of them?
2 in parallel, so you got to do a branch now.
And then
Right. Then you drag and drop the branch on to the left side of that.
like that?
No. Click on the right side of the branch. Now click and drag it over to the left side. Drag it on over. I think you don't let go of the button. You drag it over and then let go on the left side of the contact. You got to hold that left button down and drag. Keep dragging and go well on over. Now let go. There you go. Now click the lower left corner. And now add another examine off. That's it.
All right.
And now call that driver door limit switch and passenger door limit switch. That's going to be your left and right doors on your pickup truck.
Damn it.
Well, you got to right click and hit new tag. Yep. So that'll be driver door switch. The circuits that you guys are creating here, those are your basic ones that you can think of whenever you're trying to modify equipment or troubleshoot equipment for that matter. That you understand how these fundamental circuits work, and it's going to help you a lot whether you're troubleshooting or modifying or creating stuff on machines. Now, what happened there was your cursor was on the passenger door switch, and when you added another instruction, it appeared to the right of it.
Right.
So you have to hit the junction to the right of those instructions, so that the next instruction appears to the right of the cursor. So you got to actually put that cursor in a position so that it's the next instruction is going to go to the right of wherever you're pointing to with the cursor. So no, you don't stretch the branch. Go up top and choose an output now. And it places it to the right side of where the cursor was.
Okay.
And that'll be the interior light in your truck or car. Good. You got to create another one more rung. Not a branch, but this is going to be memory logic here. So for this one, for simulating purposes, you'll start out by doing an examine all for your stop button.
All right. So you want one of these?
Right. Just for the emulator. When you do the real thing, it has to be examine on.
Okay.
Because you'll have a physical button tied to it then that is normally closed. So right click and call that stop PB for push button. Okay.
So,
Now
I got a question.
You want to add a rung to it?
No, you got to choose the start button now.
Okay.
And after the start button, then you got to get the output and then back up and put the branch.
All right.
That'll be, but you have to have it examine on though. You got the wrong kind of contact there. You can, yeah. Yeah,
Yeah.
What? Yeah, okay. What was your question, Roger?
Whenever you go to test these on the actual PLC, will it matter that you're getting a bunch of different inputs from the other stuff that's running too? If they both meet?
It will. So
matter?
we're going to disable. I'm going to force off all the outputs except for the rung that we're testing at the time, because it will start triggering
Okay,
It will start triggering
All
other
right, I was just
outputs, like you
checking.
said. Yeah, you're exactly right. It'll do that. Yeah. So I'll go through and let you see me force all the outputs off except for the one that we're examining. You know.
Okay.
Okay. So now you can put your output energize in, Jamie. And that'll be motor starter 1 coil. Okay, now click your start button. Y'all watch closely if you haven't done this yet. Click the start button. And now create a branch around it. Okay, now you will drag and drop that branch to the left side of the start button. Let go. Click lower left corner. And get another examine on. That's good. Now this time, we're not going to create a new tag. We're going to reuse a tag that you created for the output coil. So if you will double left click the question mark and open the drop down. And now you scroll down and you find where it says motor starter 1 coil. So you're going to attach to a pre-existing tag.
All right.
Right. So you're attaching that contact is going to trigger off of that output. That's what we're doing now. We're doing a cross reference to it now. Okay. So you can double click. Now hit the enter key on your keyboard. And now, so what's going to happen is when you press the start button, the coil is going to come on, and that coil is going to trigger that parallel contact there, which is a holding contact like you did in motor controls. Remember wiring them up, Jamie?
Yes, sir. So you hit the start button, it's going to circumvent it, go around it, and keep it going.
Right, and this is called a logical holding contact, not a physical. So it's not, you didn't have to really wire it up to get this function. you just had to program it. So it's called a logical holding contact. So you're good to go. So
What I need to do to save this? I don't remember the steps to do that.
go up to the upper left of the screen. There'll be a blue square for save.
Okay.
Right, you hit that. And it looks like, okay, you're fine right there now. The one thing I forgot to tell you to do is before you hit save, go up over in the center of the screen, and there'll be a green check mark for verify.
Mhm.
Now, if you hit verify, it will check for errors right then before you save it.
Okay.
And that's a good habit to hit verify before you ever do anything else. So,
But once we saved it and didn't have any errors, we're good.
right, yeah, it actually checked it when it saved it, I believe it, because it showed you that there was no errors. So,
Okay.
yeah. So anyway, so you're set now. Had you already turned on your emulator?
Yeah.
Okay. And had you already set up? You had already configured RS links, hadn't you? Well, actually, yes. Your processor's actually off.
All right. So what do you need me to do?
Well, you need to bring your emulator back up because there's a big red X mark on your processor. So if you'll right click on that, I think you're going to have to probably reboot the emulator. No, go over on links. Go over where links is in slot 0 and
All right.
click it. Right click, start links. Yeah, you got to cut links on because you hadn't turned on links outside of the emulator yet, so you have to cut it on from within. And now right click on slot 2 where your CPU, your processor is. And it says it's not responding. So the best thing would be to shut your emulator down and then cut the emulator program back on.
Okay.
So just X out of that screen, and let's see, does that fix it? So you can minimize this screen and then go back out and turn the emulator back on and see if that fixes it. Right, that fixed it.
Okay.
So you can pull your studio screen back up.
All right.
And now scroll up to the top and go to communications in up to the upper left. And who active. And now you want to highlight your emulator. And now hit download. You're pointing to the emulator like you would point to a real PLC. You'll find out a little bit later this evening that when I do your real program for the real PLC, you got a real program, but when you do it for the real PLC, you will observe doing this through an Ethernet cable to a physical PLC. But it looks the same. What you're doing right now, you are getting the real feel for what it's going to do on the machine. It's just the processor you're pointing to, instead of it being an emulator processor, it's just going to be a real Allen Bradley processor. That's the only difference. So you're getting some very good practice here. That's very close to real world, very close to it. And now go to your upper left where it says REM program with a blue window, and you're in remote program now. So you got to do the drop down and go to run. That's it. Yep. And now you can go through and right click and toggle each one of your contacts and test your logic. Okay. That's it. Good. And just do one of your thermostats. One of those will be enough. We know it's going to do it on all of them. That's it. All it took was one thermostat. It could be three different ones in an area. Okay.
Right.
And now do door switch 1 and thermostat. Good. Great. And it could have been door 2 and the thermostat would have been fine there till you got your or and your and. That's good. Now close your refrigerator door. Great. And that cut the light off. That's good. And then trigger one of your thermostats. Good. That's great. And you're going to shut the driver door. Lights are still on.
Yep.
Now shut the passenger door. Perfect.
All right.
Right. So, these different functions, you can just think about it, for wherever you work at. Okay. So now if you'll toggle the start button and then untoggle it. And now you toggle again. So now it's staying on just like when you did it in motor control, Jamie, you did the physical one. It's doing the same thing.
Using that as a holding contact.
That's right. It's a logical holding contact within the emulator. Yep. So if you'll go ahead. Now hit the stop button. Now you got to cut it off. So trigger your stop button, toggle that, and then untoggle it. Notice did it cut the coil off? Now untoggle. Yeah. Now you're back to square one.
Right.
So that was the same effect of pressing and releasing a stop button by toggle again.
Yeah.
So that's good. Okay. Let me put you down. That's a 100.
Thank you, Durwood.
Yeah, you're welcome. Now you can start creating the real thing, and I can watch somebody else's emulator.
Right.
So you'll create a new project with the processor name instead of using the emulator processor. You'll use the stuff on the top of that paper that I sent y'all today. Yep. You could actually open that PDF on your phone if you wanted to. If you didn't want to try to open it on the computer.
Yeah, I took a screenshot of it.
Okay. So if you want to cut your screen share off, let me find out who else I can check. Doing that. Let's see. Eric Martin. Let's see. Eric.
Let's see.
Jameson Smith. I seen Jameson. Justin. That's good. And then Kenneth. Okay, so I've seen everybody's emulator that's in the group right now. And let me double check the attendance roster here. Make sure I've got everybody in. Kelvin. And right, okay. So that's good. So now we can start on phase 2 of me putting your real PLC program in this PLC here for you to see it run. So the first person to email me one was Kenneth McKelvin. Is that the right way to say your name? Is it McKelvin?
Yeah, that's right.
McKelvin. Okay. I was saying McElvain. I didn't know why before I heard before I heard Nathan pronounce it. I didn't know how to pronounce it right. So
Yeah, it's Scottish. Everybody messes it up.
McKelvin. Okay. All right. So where are you from? I have never heard that name.
Well, I'm from Linden, North Carolina, born and raised. I moved out here when I married my wife. And been out here since.
Right. Okay. So does anybody have a question so far? Has anybody got problems that we can help you with right now before we start demonstrating the PLC version? Okay. If anybody's hitting a snag at any point, just say the word and we'll take care of it. And so So with that being said, I'm going to open up a program that Kenneth sent me and let you see all the logic and the addressing the way he did it, because he did it perfect first time. And then we're going to go through, I'm going to trace the wiring on this PLC that we have here, the input and output wiring. I want to physically show you how it's wired before we actually run it, and then run it. So let's first of all let's take a look at this program. Do y'all see his screen? Do y'all see my screen there?
What? Yeah, we see your screen.
So if you notice here on the tags there, you have an alias tag. Matter of fact, if I hover the mouse over it, do you see the window that pops up with all the descriptions for that tag?
Yeah. Yeah, we can see all the.
It tells you the tag name, and it tells you that it's a tag type as a bool. B-O-O-L means Boolean, or it's a single binary bit. So that tag is a single 1 or 0. So that tag, the data for that tag uses one binary bit, and one binary bit is called bool, B-O-O-L, short for Boolean. Boolean is a mathematical term like Boolean logic. But Boolean logic is and, or, nor, not. So if you can Google it, but the type of logic that we're doing right now is called Boolean logic. B-O-O-L-E-A-N, Boolean logic, which is digital logic of ones and zeros. Something's either on or off. So let me hover it back over there again. So it says the data type is bool, which means a single bit. It's an alias for a physical input. So by hovering it that way, you see all of the information about that and the scope of the tag, which means where is it at and how wide of a scope is it? How wide is the availability of the tag? It's available for the main program only. It's for scope. So scope would be, if it's main program scope, it's called local scope. And if you put that tag in the main controller tags, it's called controller scope, which would be a wider availability, or called global. Global and controller scope is the same thing, which means it's available for any routine in the machine. And local scope would be that tag is only available in the immediate program that you're dealing with. So here he has local 1. Now, what does 1 mean?
That's the first module.
The first module, which if you look at it in my webcam, slot 1 or module 1, and there to go slot 2. I'm pointing at it with my webcam there. That's slot 2, local 2, local 1, local 2. Okay. So it's local slot 1 and I. What does I mean?
Input.
Okay, and then data.3. What does the 3 mean?
That's your physical location of the output.
Or the input. Yeah.
Or the input.
It's the physical location for the input. So it's going to be input 3, number 3 input in slot 1. And then he's got input 4 and input 5, 3, 4, and 5. So all of that matches the drawing that I'm holding up here that I sent y'all today. It is showing those limit switches of being input 3, 4, and 5 on the wiring diagram there, or the schematic. Okay. So, and then for the output, you have local 2, because I've got all the outputs is in slot 2. Here, when I'm pointing at the webcam, slot 2. The reason I'm using another module for the outputs is because the outputs that are in slot 1, they're DC outputs. They can only handle 20. They only provide 24 volts DC from the outputs that are in slot 1. So slot 1 has 16 inputs and 16 outputs, but it's all restricted for 24 volts DC. Now, the devices I have down here at the bottom of the screen that I'm pointing at down here, the devices that are down in here, those motor starter coils and the light bulbs, those pilot lights, all of these are 120 volt AC, 120 volts AC to actually drive those devices there. So slot 1 cannot drive those devices. You got to put another module in. That's actually a relay output module with 16 relay outputs. And if you notice on the wiring diagram that I have on the output diagram, I put I'm going to get closer to the camera here with that. On the output module, can y'all see that? Can y'all see that drawing there, or is it fuzzy looking?
Yeah, we can see. It's pretty clear.
So for the output module, I tied 120 volts right here. 120 volts AC. I went to a terminal called VAC1. It's VAC or VDC1. So whatever voltage that you connect to that terminal, that same voltage is going to be used on these outputs. So you determine whether it's going to be an AC voltage there or a DC voltage. I could have put 24 volt DC there, but I didn't want to. I wanted to put AC. So you can put AC or DC on that terminal, and that terminal becomes the power supply for all of these outputs out here. Okay, does that make sense? Is that making sense?
Oh, yeah.
Yeah.
So you have to physically put a voltage source there so that all of these outputs have somewhere to get power from. These are all relay outputs that are inside of that module, and you have to be specific on what you put that it's compatible with these starters and these pilot lights. Okay, so that's the difference between this module is AC output versus these are DC inputs for your buttons and your limit switches. Okay, no, everything up here you had 24 volts here. 24 volts DC here feeding your input devices, and then they provided 24 going in right there. Is that drawing? Can you see that drawing, or is it fuzzy looking?
I can make it out.
Okay. All right. So, on his, let's see. He's got input 3, 4, and 5 in series there, and then the output is coming out of slot 2 for output 0 for the MCR. And the MCR I'm pointing at over here is at the bottom left. Down in here, that's the MCR relay down there on the bottom, the first one on the lower left of my webcam. So it's right in here. Okay, that's the physical device there. And then he has those same inputs in parallel for OR. And then he's choosing output 1 in slot 2. And that's going to drive this other starter right here I'm pointing at in the webcam. So it's the second contactor, or this is a complete motor starter here. That's going to be the one there. You scroll down. And he's got the safety gate limit switch 1 and 2 here in parallel, a third one in series. Now, this in real life, it could have been two door switches and a thermostat. So it doesn't matter. I mean, what we're calling them right now, you just know that you have OR and you got AND right there. And the real address is at the input 3, 4, and 5. And it's going to give you output 2 over here in slot 2, which would be this starter over here that I'm pointing at in the webcam. It's going to trigger that one. And then his this in here for input 3, we were calling that the refrigerator door limit switch is what we were calling it, even though the name is not saying that now. You're sharing the same name. You're sharing input, so you can't rename them, okay? So just keep in mind that this is the not logic, and it would actually be like a refrigerator door limit switch, or it could be a safety gate, or whatever you want to call it. And that's going to trigger the green pilot light that's over in the webcam way over here. So this one input over here with that switch is going to trigger that green light, this output 4. Your NOR logic, your two examine offs, they're going to be, that's input 4 and 5. That's going to do the yellow pilot light over here in the camera. And then your NAND with your vehicle door switches, input 5, he did input 3 and input 5. And you could have done 3 and 4. You could have done 4 and 5. It doesn't matter as long as you pick 2 of those limit switches. He's got those going to the red pilot light, which would be over here in the camera in the bottom light. Okay. And then lastly, his memory logic, he's using, and you notice here on the stop button, he's got an examine on, not an examine off. And the reason for that is this. It's in the schematic. And I'm going to go back to the screen here, back to the webcam. What kind of a button am I pointing at right there in the webcam now? Can you make that out?
That push button.
Top button.
It's normally what?
Closed.
It's normally closed.
Someone close.
Now you've got a physically normally closed button outside of the PLC feeding the PLC. So you've already got normally closed there. The instruction in here needs to be an examine on. You don't want to use a normally closed out here and an examine off in there, or you're going to end up reversing and canceling out the logic of this. So the instruction inside the PLC is going to be an examine on like he's doing. And because this contact is already closed physically, you're going to get voltage coming in. And by voltage coming in to input 0, that instruction of it being examined on, it'll be lit when this button is actually, when you let go of it like that, and it's actually made already by releasing it. Voltage coming into it will satisfy that instruction. Because the instruction, an examine on instruction is looking for voltage coming in at a physical input in order for it to be true or green in the logic. For it to be illuminated in green, you got to have voltage coming into that physical input. And we're going to illustrate that with the physical PLC in just a few minutes. But just remember that the reason why we changed it in the logic and made it examine on is because the physical button right here is actually already normally closed in the real world. And so the instruction in the program needs to be examined on, and that will actually give you what you're asking for. And the start.
In other words, we just need to flip that one gate.
Say it again.
Oh, we need to flip both. Do we need to flip both of those gates then?
Both of the gates.
Never mind.
We're talking
Never
about
mind.
a stop button, a start button right now.
Yeah.
We're talking
Yeah,
momentary buttons. If I point down in the webcam down here at the bottom, that I'm pointing in the camera, a green button and a red push button, not switches. You know?
Yeah, I was following on.
Okay.
Yeah, I was understanding.
Now, so
it's going to be normally open.
Right. Now, what kind of a contact is that right there that I'm pointing to in the webcam?
Normally open.
Normally open.
It's normally open, and in the program you're gonna have an examine on that's gonna be looking for voltage. So when you release a start button, the instruction is not going to be illuminated. It's not going to be true. But when you press the button, you get voltage coming in. That instruction will be true at that point. So for both of these instructions for input 0 and 1, you're going to use an examine on. Now, I know you're probably thinking that's not making sense, but you got to realize what is the instruction looking for. If you use an examine on instruction, that instruction is looking for voltage to be illuminated in that program and be true. So because of that normally closed there on the input 0 and that stop button, you're going to always have voltage there if you let go of the button. If you're not pressing the button, there's going to be voltage there. So you got to use an examine on instruction in the program to work in conjunction with a normally closed button. For you to get the effect that you're looking for, you have to have that. Okay. And we're going to go through. Is there
a way to flip it without deleting it?
Is there a way to flip it without deleting it?
Yeah, change it from normally closed to normally open. because I had the normal closed on my circuit.
Yeah, you can do that. Yeah, let me cut my. I'll cut screen share off. Cut your screen share on, and I'll show you how to do that.
Gotcha. Yeah, because I was just looking at what I did before, and I didn't think about it not being one.
Mm-hmm. Yep, you're having to flip it because of the physical button that we're wired to. So you double click in the center of the contact. Don't right click. Double click, double left click, and now where it says XIO, you're gonna choose XIC for examine on, examine if closed. That's
Okay,
it. Right. That's the one that you want to hit enter, and hit enter again.
all right.
And now that's fine. Okay.
All right.
Right.
So that's something you have to think about versus like program it, run it on a software versus actually run it in real life, you know.
Right. That's the only difference you're going to see really between the emulator and the real physical PLC. It's when you have a normally closed device in the real world wired to an input, then you're going to use an examine on instruction in the program in most cases, not in all cases, but in most cases, so that you don't cancel out the effect of that device. If you use a normally closed outside physically and you use an examine off in the program, it's like a double negative. You're going to end up with the opposite of what you're looking for. It's just not going to give you the function that you're looking for. If you use normally closed inside and outside the PLC, you're not going to get what you're asking for. You can only use the normally closed in one place, either one or the other, but not both. Okay, so
Understand? Gotcha.
Okay, good. And we'll go back to Kenneth's program. So he had input 0 for his stop button, input 1 for the start, and then the coil is output 3 for the starter number 3 coil. And then this address here, local 2 output 3, he used that same output tag there, address, for the holding contact, local 2 output 3. So this address here has to match. It has to match this output so that output actually will trigger this to seal in around the start button, which allows you to let go of the start button. You momentarily press the start, it triggers the coil triggers this, and then it just runs kind of a branch around like that without you holding the start in. So his addresses are all correct. And if you notice here, I've got some things forced off in here so that they're not going to trigger physically to confuse the situation while we're running. We're going to test one line at a time, and I don't want 3 or 4 things coming on because we're sharing inputs. It would be kind of confusing. So anyway.
I was thinking that when I was writing it, but I didn't want to say nothing.
Right, yeah, because we're limited on how many devices I've got on this little plywood board here. It's a small board I brought home, and I could have brought home a 4x8 plywood and done it, but I ain't got room in the room here. So so we're limited. I've got it scaled down, and you can still get the effect of what you need by what we're doing. So now,
Makes sense.
So before we download and run it, let's go over the wiring real quick, the physical wiring of it. So do y'all see the wiring diagram there, or schematic?
Yeah.
All right, so we're going to focus on the inputs right there. Now, if you take a look here, for slot number 1, we have this. 24 volts is coming from a little power supply. I'm going to show you where that is on the board. The 24 volts actually goes to one terminal on the stop button. The same 24 feeds one terminal on the start button. That 24 is present on the left side of every device, of every input device. So there's a hot leg of 24 volt DC on every.
Somewhere on Sampson County. Wow.
I see McGill. Hold on, let me get McGill in here. How you doing, McGill?
What's going on, Derwin?
Did you finish up your emulator? Hold on. Yeah, you did. Yeah, I saw your emulator. I saw that too tonight.
Questions, but
so you were working on your real program. I think you finished it, didn't you?
I did, but I wasn't sure if I had did it right because I did it that same night, and I didn't know if I had did it right or not. That's why I emailed you yesterday, but I didn't look at it until like yesterday evening or today.
That's fine. We'll get to you in a little bit, and we'll let you do a screen share, and we're going to look at your program before you send it to me.
Okay.
Okay. So you kind of be looking at what we're doing here, and if you spot anything you need to change on it, then you can do it. So
Yeah.
everybody, okay.
Hey, Derwood, got a quick question.
Okay.
If there's stuff we got to change on it, right? How do you do that?
What do you mean? How do you do
All
that?
right, like mine, I kind of messed mine up. I thought I did it right, but I didn't.
All right, let me cut screen share off. All right, go ahead and show me what you got.
That's what I'm trying to get to now.
I see Justin Sessions. How you doing, man?
All right.
Did it finish downloading?
No.
It's still downloading?
Yeah, Darren's here with me too.
Okay. Darren, how you doing, man?
All right. We're waiting on his computer to turn back on so we can start his I'm gonna try to get his stuff downloaded too.
Good.
Derwood,
Uh-huh.
I got Windows 8 on my computer. You think it's gonna work?
Is it plain Windows 8 like Home Edition, or is it Windows 8 Professional or Enterprise?
I don't know. I'm gonna have to wait till it comes back on.
What happened here?
It ain't gonna work.
I'll let you know. We're gonna start downloading.
Listen, if it's not Enterprise or Professional, it's not going to work.
All right.
Mine didn't work. I had to get a different computer.
Right. The only Windows 8 that's going to work, and I can show you. Let me show you, Darren, what I'm talking about. So in just a second, let him show me what's going on here, and then I'm going to show you how you can know about your computer.
All right. Ain't it the same way? Derwood, ain't it the same way we looked at mine?
It's the same way.
Yeah, I'll just check it later then when it comes on.
I think I did my local 2s all wrong. See how I got set up, Derwood?
Local 2 output 0, output 1. That's fine. No, you're doing fine there. What makes you think it's wrong?
Oh, because if you look right here, I got data 6 on this one. Local 20 data 6.
Well, yeah, that's not good there. No.
Okay, so how do I change that then?
Okay.
And that should be data 3, right? On that local 1I?
Right.
So how do I go back and change that?
Okay, so go first of all, go over to the coil.
Okay.
And right click on your tag.
Okay.
Now you got to go up higher to right click. Now go up to edit properties. Okay, now go under alias for what? And you're going to repoint to the right output that you want to go to.
So I want that on what was it? I gotta get that paper now. Don't tell me, Derwood. Let me see if I can figure that one out.
Right.
All right, that one's got to be on data 3 then, right?
That's right.
Apply.
Right.
Okay.
That's good. And now you want to do the same thing on that one. Make it the same thing.
Oh, wait. All right, gotcha.
Edit you're editing the properties of that tag.
Right. Left click.
Okay. All right.
There you
Local.
Local 2 output.
No.
Local 2I.
Hang on.
Local
Is
2O.
it,
Local 2O.
Yeah, that's for output. And then go for data.
hang on, what?
Click beside data.
Yeah, I got it.
Right. And now it's going to be 3. Yeah.
3. So that'd be the same thing as
As the output.
the output. Okay.
Because the output's going to trigger that contact.
Shouldn't they have used the tag?
He already had the tag created, Roger. He just had to change the physical address for the tag.
So basically, this one and this one's got to be the same.
They have to be the same.
Okay.
Because the coil triggers the holding contact.
It does the suit does. So does alias not affect any?
Do what?
The alias, the name above the local .2 mess. Does that not affect it?
I can't understand. Make
They
out what
didn't
you're
use the
saying.
same-
I guess he's talking about this right here where it
They
says
didn't
motor
use the-
starter coil and then M
Yeah.
starter coil. But the reason why I had to do that, it would not let me do
Yeah,
2
'cause-
motor starter coils
No,
at that
no.
time.
You shouldn't have.
You had to left click.
You see what he's talking about,
You had to
Darwood?
double click.
Yeah, you're not supposed to be seeing it different. Like it's supposed to be the same exact tag.
And see, that's what I tried to do, and it wouldn't let me earlier. Let me see if I do it
Well,
now.
look, go in there and
No, you don't. No,
don't,
you don't.
don't change that. No,
Not like
Okay.
that.
not like that. Go to your contact.
gotta
Your hold,
delete
go
that
to
one
your
you
holding
got there, right?
contact.
Hold on, Darwood. Say that again, Darwood.
Go to your holding contact.
This one?
The holding contact is below,
Oh, this one.
right there. Now right click.
Right click.
I
Okay.
mean, I'm sorry. You had to go a little higher up to the address and then
Oh,
right
yeah.
click. So the problem right there is you had actually created a new tag and you don't want to have a new tag.
Okay.
You don't
So what
really
do I need
want
to do?
that. So basically just get rid of that instruction. It's going to be quicker just to get rid of it.
So cut instruction, is that what you want me to do?
Or just, yeah, you can say cut will be fine.
Okay.
And now click the lower left corner of that.
Right.
And now just get you a fresh instruction. Just get you another examine on. Yeah. And now don't right click.
Oh, don't right
No,
click.
no, sir. Don't create a new tag.
Okay.
Double left click on the question mark.
Okay.
And do the drop down.
Ah.
And now go down and now you just re-choose that same tag. So anytime you're gonna
This
connect,
one right here. The M starter coil.
that's it. That's it. Now hit it.
Okay.
And now hit enter
Where's that at?
on the keyboard.
Yeah, I know. I was a little slow on that one, Durwood. Sorry.
Right. So that's the way you have. That's the way you actually match those. Is you just go in and you're just reusing the same exact tag that you had over here.
So that's why it wouldn't let me do that when I first made the program then, because I did the motor starter coil and then I tried to write motor starter coil. I wrote it here first, right? Now I try to write it here again and it wouldn't let me.
You can't do it.
Yeah,
You only
I see
write it
now
one
why.
time. You only write it
Yeah.
one time.
Okay. But now the rest is right with all my datas?
Well, you got to go up now. So the interior light is going to be actually
Let me see.
will be actually output 6. So you got to change it from data 5 to data 6.
Okay. So now that's
Right click and edit, edit properties.
Edit. And then go to data 6.
Yep. And then your heater unit would be, it's actually going to be a pilot light of the yellow pilot light output 5.
All right. See, that's the ones I was having problems with right there.
Right. Yep. That's good. And then the one above it for your courtesy light, that's going to
That'd
be,
be the
that'll
red
be,
light.
that'll be 4.
That'd be 4.
That'll
Green
be
pilot.
out,
Okay.
output 4 because it's going to be the yellow light over here on my board here.
Oh, I got green on mine. I might have downloaded the wrong paper.
If you look on the camera right here, you see the output there.
Yeah.
Yeah.
Yeah. Okay. Yeah, I got the one with the data 4 is green, 5 is yellow, and 6 is red.
That's it.
So now what did we say this one was? This one was 4, right?
Uh-huh.
Yep. Okay. Apply. Okay.
Yep.
And then the rest should be right?
Right,
Data
to go
1.
on up, your fan's output 2.
Got refrigerators 3.
Hold on. No, wait a minute. The refrigerator output is supposed to be the yellow light, which is 4.
So that should be a yellow light too.
One you just changed should have stayed at 5, and you should change that one to 4.
Yeah, I got mixed up there.
Okay. Okay.
So your
I understand now.
your courtesy light on the refrigerator should be 4.
And then the other one needs to go back to 5.
Yeah. I don't know how I got mixed up on that. Yep. Sorry about that. My bad, as they say. My bad. My bad.
I'm trying to learn this, so.
Right.
All right, now the fan, that's right. Or no?
So, yep, that's right. That's gonna be output 2. That's right. And then above it, your OR logic is output 1.
Right.
And then your AND logic is output 0. That's right.
Okay.
And
The
then
only ones I was having problems with then was the ones with lights then.
right, I just reserved them for not, nor, and NAND.
Okay.
Because I would rather see lights on them. You know, I've got 4 starters here and 3 lights I mean, I could hook up more stuff here, but you don't
But
particularly.
now, if I was doing that in real life, would it have been right if the way I did it, or no?
Would what have been right?
Okay, if we wasn't using lights for the situation, or would you still have to do it just the way we just did it?
Yeah, you would have had to do it the way we did it because you can't reuse outputs. You got to have a different output for every rung.
Okay, that's why
Every rung's got to have a different output.
Okay, that's why I was making sure.
Right. And what it is, I had them kind of mixed up there because the arrangement I've got here is I wanted to have your last logic for memory logic to be able to use a starter, the last starter, which would be, starter 3. And the order of my outputs didn't stay in order with the logic, if you know what I'm saying.
Right. Now I just hit save, so that saves all the changes, right?
It does.
Okay.
Yep.
And what I'll do is I'll resend this to you. The first one will be obsolete then that I sent to you.
Right.
All right. Thank you, Durwood. I appreciate it, man.
Yeah,
I was really confused on that one.
Yeah, well, I kind of got you. I got you crossed up there too. I'm sorry about that.
That's all right. That's all right. We got it though. That's all that matters.
It does. You're doing a fine job there.
All right.
So there you go. And now I'll cut my screen share back on. So Kenneth McKelvin, this is his circuit here, and just before we download it, let's go over the wiring real quick here, the physical wiring, because that's something that I regret that you're not able to do at home is the wiring of the inputs and the outputs. So let's kind of go over that for a minute here. And I'm going to switch. I'm going to cut off the logic there and let you just see nothing but the webcam in a full screen. So let me go here. Stop share. And let's go, let's see. So do y'all see the board here in full screen?
Yes, sir.
Yeah.
It's large. Now I know up in here it's kind of blurry. It's blurry. You're not gonna, because of, I've got it backed up so far that you can actually see the PLC, the input devices, the lights, and the starters all in one. With this camera, the best I can do to show you everything in one shot is this is going to be blurry up in here, okay? And there's nothing I can do about it because of the distance and all. And I've got a better camera on the way. It's actually a wider angle and autofocus, and but even at that, it's probably not going to be sharp in here at that distance. Okay, so we're going to go over the physical wiring first, and I've got to cut the power off. I've got this thing's energized, so hold on. Now, just so you'll know that I'm doing the same thing that we do at the school. What's that right there, guys?
Lockout.
Box.
Oh,
So that's the power cord. I'm running everything off that little drop cord there. So I'm gonna lock it out. So there goes my key. So you're seeing here that go here. I'm gonna lock it out like that. So there's no way to plug it in. Okay. So we go there, and let's see. And also, it's a good idea that even when you lock it out to make sure everything's de-energized. So we're going to cut this meter on voltage here. This meter here has automatic selection of AC and DC. Y'all see that? So can you read that writing there? Anybody?
Yeah. AC,
So,
DC.
so there's one setting for voltage here, and it detects it, and it tells you in the display by default AC. And if I touch DC, it'll flip back and forth automatically. To where this meter right here will not. This one here has AC voltage here with the wave, and then you got to physically go to DC with a straight line. You got to keep flipping back and forth on a more expensive meter. It doesn't do it automatically. Here it says AC. If I flip it here, the straight line, it says DC. You see that? So the more expensive meter that you use, you've got to have more thinking involved. What are you actually reading? You know? Okay. So for ease, I'm going to just put the big one down because it didn't work out this afternoon when I was practicing this. This one I can actually hold it plus probe it and hit buttons at the same time, and you can still read it by me having 3 arms here. So I'm having to be an octopus. Okay, so all right. So let's make sure the power's off. Okay. So the way to do this is you would go over to a circuit that's actually hot and make sure the meter is still working, that the meter's okay, and I know it is. Because I just checked power a while ago. And you would go over here to your main power section. I'm going to move the camera over this way. And this is where the drop cord's coming in. Did you see that cord over there?
Yeah.
Y'all see that? So I'm just going to go in there, and I'm going to check from hot to neutral. In that little strip, I'm going to check hot and then go neutral over here right beside of it. And you're gonna see that the AC, there's nothing there, so it's dead. You see that? So I know that I know the main power is dead. Now here, this is a DC power supply that converts AC. This is 120 AC coming in down here that comes in from that little breaker on the side. So I'm taking the AC over here to 120 coming in. I feed it through a breaker, and then the breaker actually feeds up to here to going into a power supply. It converts 120 to 24 DC. Let's make sure the DC is also dead. So I'm just going to touch up here to the plus and the common there. And we're going to see that it's also dead. So there's no AC or there's no DC or AC on the board right now. So it's safe. All right. So next thing is let's trace out the inputs. So here the inputs is we have the 24 volt DC going to the stop, start, and to both all three switches there. So 24 comes into this panel right over here, and it jumps to all those devices, and then each one of them has a separate line going into a separate input on the PLC. So we're going to trace that first. So we go into here to the panel. And I know some of y'all know this stuff inside and out, but some of you have never had a class with me, so I'm not going to assume that you already know this. So if you go over here and look, you see on the back of here, I've got the start that we're using. This is not being used right now. That's a spare. So we got start, and we have stop, start, and then there goes your three simulated gate switches. Okay. So if we go into here, there's going to be 24 volts going to all of these first. If I go to here, the 24 volts, you see right here, that orange wire, the 24 volts is leaving the power supply right here, and it goes down to a terminal strip that's over here. So it goes to a terminal strip, and there goes a couple of jumpers in there that I can come off of a couple of places with 24 volt. I come off of the bottom of there with 24 volts here from that terminal strip, and I go to the PLC. The PLC has to have 24 volts to power it up. So it's 24 volt DC PLC for the CPU section for the brain. I doubled it here with 24 volts, and I ran that 24 down in here into this control panel. So here, right there, y'all see that 24 going in right here? Everybody see it?
Yeah.
So if you look inside here, so this is the 24 volts. You see that going inside of here?
Yes, sir.
It 24 is here. Now I daisy chained it, and I went from here, which is actually one of the buttons that's unused right now. I jumpered that 24 from here. I daisy chained it down to the next one. You see it? The 24 goes to there. I doubled it. I doubled it there. I doubled it on that one, and I doubled and went down to the next button. You see that? So I went in, I put 24 hot going into this one, jumped it to this one going in. I doubled that same exact wire, and I went into this one. So what that did is it put 24 volts on the left side of all of these buttons here. Now this is unused right now, but that took care of 24 volts entering the left side of this one and entering this one. Y'all follow that?
Yeah.
Which was giving you this. Okay, you had the 24 volt going into the stop, and I doubled it and jumped down to here, okay? And then I doubled it and jumped down to here and to here and to here. You're getting ready to see this part now. Where I got limit switches at, it's actually just little selector switches I had down here. So you're getting ready to see that 24 volt jump down to those three other switches there, so that you have a hot leg going into every one of them devices that enters into it.
Darwood.
Uh-huh.
What is it that we need to look up on here to find that? I can't remember what we looked up.
Okay.
To find out what windows it is.
Okay, hold on a second. let's put this on hold just for a second, guys, and let's answer a question for him because they're in a dilemma right now. So you do a screen share, Justin.
There's some trash. I'm not gonna eat it.
It needs to be done on his computer, don't it? Darwood?
It does. It does. But listen, you steer it, and this is the way you do it. So show me the desktop. You want to minimize everything you're doing now?
Add completed.
Great. And we'll get back to that in just a second to get you moving on from where you are. Okay. So hit your lower left, your start button in lower left, and then go to control panel.
All right, I got to look at control panel.
Right. You got to get that little window open at the bottom left, that little white window open. Right. For those of you that wonder what are we doing, we're trying to figure out what version of Windows does he have on his computer, so that we're going to know is this software going to work on his computer. So you'll go under System and Security.
Right.
And now under Security and Maintenance. No, that ain't it. We got to go under System. We got to find System.
You can type sysinfo into the run bar too.
That's it. So you got Windows 10 Home Edition, which we know will work. But on Darren's, if his says Windows 8, you need to take a picture of what that is, and I need to see that.
It says Windows 8.1.
It said Windows 8.1.
Yeah.
And does it say Home Edition, or does it say Professional or Enterprise?
It don't say none of that. It's a 64-bit operating system.
It's 64-bit Windows 8.1.
Yeah.
Now let me show. Now go on yours. On yours, X that out. Now open up a new browser. So go over to the right and hit that plus. Right, and go to ab.com, and we're going to find out do we think it's going to work? And I don't think it is. So go under downloads. Everybody's watching this. This is how you find out is your Windows compatible with the software. So go under yeah, that's right. Software by Actually, no, you didn't want to do that. Actually, X that out. Close that out. I'm sorry. Go under compare products. Compare products. And now in the search bar, type in Studio 5000. This is how you find out about that. Now scroll down to Studio 5000 Logix Designer. Now double click that, and now click on version, the highest version there. And now go under compare above it where it says compare. And now choose under operating system, hit the plus symbol to open up operating systems that'll work with this version of software. Go to the left of operating systems and hit the plus symbol. Now scroll down. Okay, now open up Windows 8. And now it says for Windows 8 Home Edition 64-bit, put your mouse over the green dot. No, you don't have Enterprise and you don't have Professional. Go down to Home. It says no known issues or discrepancies, but it's not it's not guaranteed to work, but they don't know of any discrepancies with it if it's a Windows 8 Home Edition. And then the other ones that say 8.1 Enterprise and Professional. See, yours doesn't say Professional or Enterprise, so we don't really know. We wouldn't know until we tried it.
Well, you want me going to try it? Know what we'll know?
You can, but again, if we hit a roadblock, let me ask Jamie, what version did you have that didn't work?
It was 8.1. Mine was 8.1 with it didn't say Home Edition either though. It just said 8.1.
But was it a 64-bit or was it 32-bit? Do you remember?
I really don't know, but I got it right here. I can open it up and look.
If you will, that's probably going to save him some time.
Yeah, let me open it up and look and see what I can find.
Because some of the older computers were 32-bit, and if that's what Jamie's was, that might have been why it didn't work.
Now this is like a brand new computer he's got.
Yeah, mine was from 2012. It had 8.1 with Bing is what it said.
Now, but if yours was a 32-bit machine,
I'm not sure what it was.
Yeah, when
If
we
you
find
look at
that
the
out,
system, it's going to say system type, and it's going to say 64 or 32-bit.
right? If it was a 32-bit, that would have been the reason why it wouldn't work.
Yeah.
But
I just turned it on. It's going to take a little while for it to come on.
Okay. So, Darren, the best I can tell, man, being that it has a Home Edition down there, and and yours is 64-bit.
Yeah.
Yeah.
Then it would probably be worth trying. I mean, there's no guarantee with it, but they say that there's no known issues or discrepancies that they're aware of.
But we're going to try it. That's all I can do.
Yeah, that's the best thing you can do. And with Jamie, I have his pulled up in just a minute. And if his is 32-bit, then that's going to be probably the reason why it didn't work.
All right.
So you can go ahead and close this window out here, Justin. Or you can cut your screen share off. Well, actually, look, cut it back on. We got let's get your install going while we got class going on here, because it won't take but a second to start it and then cut your screen share off. So go back to where exactly. So hit open. You're going into the RA folder. All right, now double click Studio 5000. Now you want to double click part 1, and it's going to start installing for you.
It's in that box. It's in that box and write down what that number is.
Everybody, I'm not going to tie time on this. I'm just going to get him started. Once it starts the process, he's going to cut his screen share off, and we're going to move on here with Kenneth's program. So all I'm trying to do is to keep people moving, so that nobody's really left way behind. Is your screen updating? Oh, no. Yeah, let's get ready to do something now.
Somebody's helping you.
No.
He has to hit
No.
Okay, now hit extract. And what it's going to do is going to extract the compressed files.
That ain't on me.
Now, Justin, while it's doing that process there, you keep an eye on it and you let me know when it's done. And then you cut that screen share back on and I'll help you from that point. But you can cut your screen share off now. Okay, good. Okay, so now we're back to, is everybody still with us?
Yes, sir.
Okay,
Yeah, we're
good.
here.
All right, so we were looking at the 24 volts here. The 24 volts, how it's going to daisy chain down and feed these three switches here. Okay, it's going to feed the incoming side with the 24, and then you'll see separate signals leaving going to these addresses on the PLC. So let's check this here out. So back down here, we're going to be looking at our simulated limit switches right here. Okay, getting 24 volts on each one of them. So the 24 volts came in right here. It came in here. It daisy chained from one push button to another one. The same side, the same hot side, jumped down to another one. And then it jumped over to the switches. You see, I'm jumping that same 24. I'm doubling it, what we call double. So I double from here, and I go to one switch. I double it there by putting two wires in there, and I jump up to this one. You see? And then I double it this one and go to the very last one up top. So that's a 24 volt bus line there that I've got jumper to all of the devices that are coming in on one. That 24 volt line right there jumps. It jumps from there and it daisy chains to all 6 devices, so that you have a 24 volt leg leading into every one of them individually. They got a hot leg on the left side of every one of them, signal wires going into the PLC to these addresses. So now let's trace out from the stop button to input 0 and how it gets into the PLC. And once we do this one time, I'm not going to do it again, and so to tie up your time, but we got to go over it one time. So we leave the stop button and we go to this input on the physical PLC. To how do we get there? So there goes the button. There goes your stop button. Okay, this is the 24 volt going in. Now this is the signal leaving it right here. Okay, that's leaving the button. That's the signal. So here we go back and we trace out of here. Where are we going? So I'm going from the button out of the box. And I go to and then look, then I go to a terminal strip first. Okay. Hold on. Wait a minute. It's this one. The stop button is this one. I had the wrong one in my hand. The stop button. The stop button's here. So it's this one here. I leave here. And then I go out of the box. I'm going to here. Come over to here like this. And it comes over to here. So you see that orange wire there?
Yeah.
Now where's my pointer at? So this is the wire that leaves the stop button that's going right to that terminal. So these terminals, whatever goes into here leaves and goes out of the top. These are all separated. I mean, you know, what goes in the bottom leaves out of the top, but everything side by side is isolated. Okay. So this one here, that orange wire, that's actually leaving the stop button in here. And then it goes from here. Now pull this. You see that wire there? That one right there is leaving it, and it goes up to the PLC. So this is what's leaving the stop button. Let's take the camera and go up here. And that's the wire I got a hold of. Now I'm going to reposition the camera so you can see what's going on. So just get ready for that. So the input is right here. It's the top wire. Do you see that top wire there?
Local 10, right?
Right. Now look, that top connection, that's a push-in connection. I'll show you how that works. But that wire there, that wire correlates to DC input 0 on the left side where it says 0. Can you read that 00?
Yes.
All right. So that wire, when you push it into that terminal, it refers to that sticker over it. That sticker says that top left is actually input 00. That's 0. And this other row over here I'm not using right now. These are push-ins, and they actually, once you push them in, the whole thing can come out like that. So if you had to replace the PLC, the whole wiring harness comes out like that through a quick connect. And we go back in with, plus there's 2 rows of those. So it's a very fast plug and play. Now, the way I got the wire into that one is like this. So watch closely. You'll take a little screwdriver like this, and you push into a spring right there. That orange thing has got a spring, so I got to push. So when I push in like that, the wire comes out. You see that wire? So you strip wire with a wire stripper. Where's my strippers at? You cut and strip wire with these, and that's like a number 18. That's a 18 AWG wire there. And so on this one, you get where it says stranded, and you would go to 18, which would be right up here. You see where it says 18? It's not going to be too clear in that camera, but you go to 18 where it says the word stranded. That's for stranded, that's for solid wire. Stranded wire, 18 is going to be up in here. You use that hole to strip it with so that you don't end up cutting too far in and actually losing some of the strands in there. It's got multi-strand like that. So there's little strands in there. So you strip it back like that. And you have to experiment on how long that is, on how long to strip it, because you want it to go in. You want to go in and get a good bite in the spring loaded connector in there. So let me go down further. Okay, now you see better. Everybody still with me?
I'm here.
Yep.
Now watch.
Yeah, I'm here.
So
Yeah.
I'm going to press in right here. I push in like that, and then it's going to let me put the wire in the hole, and then I let go. So I'm going to go way down in the hole like that. I think I had some strands that kind of got, if they kind of want to fan back on you like that, you got to get them straightened out. You don't want any strands sticking out, hitting something next to it, because then you're going to have a short circuit. So you push in like that against the spring, go in very carefully down in the hole like that, and go all the way down in there until it stops. And then let go with your screwdriver, and it locks in. You see that, how it locks in? And then you examine, did you have any strands sticking around? So you want to look under it, and there's no strands out there. You see that? So that's how I wired those individually. I stripped them, twisted them, and then I put them down in there. Now, this is kind of fuzzy looking right here at that closeness there with this $30 camera, but I got a better one coming. But to get it where you can see it better, I can back it up some. You can actually read that, can't you? That's input 0, input 1, and 2. And I actually skipped 3. You see there's a gap in 3. I don't have 3 wired yet. I've got that reserved for a hand-off automatic switch that we're going to use on the next lab after this stuff. So I've got input 0 and 1, and I skipped 2. Then I've got your switches are 3, 4, and 5 right here. You see that 3, 4, and 5, and so that correlates with 3, 4, and 5 over here. And then the last thing we're going to go over is the common, the DC common. That gray wire is in for common. So you got to put a 0 volt common wire for the DC power supply has to go in common. And there are 2 rows of stickers here. So that left row sticker is going to correlate to these connectors. And then the right row is going to correlate to that right side of labels over there for the other higher addresses of input 8 through 15. Everybody follow?
Yeah.
Yep.
Okay.
Yes, sir.
So that left side's going to be, it's going to correlate. You got to count them down because the sticker's not right beside of that lining up. So you got to count them down 1, 2, 3, 4, however many of them, and count the sticker positions to get the wire in the right hole, because they don't have that sticker's not really scaled to this, not directly side by side. So I had to count down, you know, like here you got 0 through 7. That would be eight positions. And then the 9th position would be the common. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9th position is common. You see that? That's common because I counted down 9 positions on the sticker, so it's the 9th hole there. So let's find out, where did that common come from? The common came from the terminal strip down here. And then I've got a double jumper in here. That yellow is a double jumper down there. Let's see. So I came from the PLC common right here. I went into a yellow jumper set here. That double means that all 4 of these are common, like 4 of a kind here. So all 4 of these terminals are the same because of that jumper set in there. I left here. This is what comes from the actual power supply. So let's follow that wire over like that and come up. I got to bring the camera up. If I had a cameraman, I'd have it made, but I don't. You're looking at him. Cameraman and instructor. So that gray wire came from up here, guys. See that? So it came from the DC minus, 24 volt plus and minus. That's your common that has to go to the PLC. That ends up over here because I'm actually tugging on both of them right now. That gray wire goes down to the strip and comes right back up to that common. This for that input group there. See that? Now, so if you were going to wire more inputs, if you were going to use the inputs that went from input 8 through 15, then you got to put another common on this other side over here. You have to go beside that gray wire and put another common in there for this group here. So each set of inputs in those groups have to have a common of their own. And then that will be input 8 through 15 there. Now, if you're using outputs, we're not using any DC outputs, but if you see up here in the green area, it says DC out. So these are 24 volt DC outputs. There's 16 of those. Those are in the bottom half of the connector, which would be down from here down. So if I go down to this area, starting, it's green here, all of these are outputs. So this is, you'd have to put 24 volts in there where it says V plus. You got to put 20, I'm not using any DC outputs, so none of that's wired. All of my output devices have to be AC controlled, so we moved over to here, okay?
So what would you use DC output for? Like
if my lights were running off of 24 volts DC, then I would use the DC outputs.
Gotcha. That makes sense.
But these lights are actually wired. When I got them, I bought 120 volt lights.
Yeah, I suppose that makes it simpler for doing it at home.
Right. So if if these lights on this schematic, if they were 24 volt lights, then I could have wired these lights up to these DC outputs right here. I'd have been fine. I could have used the embedded outputs that are embedded in there. Okay. Because you got 16 in or 16 out, everything's DC. I could have used that, but I didn't have it. Now on the automation system at school, Roger, those lights that you had there, all of those lights were 24 volt DC.
Okay.
They were, but what I have here from motor controls, all this stuff is from the motor control class, so it's all 120 volt AC. As far as the actual the voltage of the devices, the starters, all of these motor starters are all 120 volt, and then the lights they're 120 volt also. So we're using this module here. This is a relay output with 16 relay outputs, and we put 120 volts on there. Okay.
Gotcha.
So now the next thing before we download this program is this. If we go to, let's go up. Now the output section here, the 120 for slot number 2, you take 120 volts and you put it on VAC VDC terminal 1. So that's the first thing you're going to trace out. It goes to there. Power for all of these here is supplied to that one terminal, and it gives you. Then that's what all these pull from whenever they activate from the PLC. So let's trace the 120 volt into that terminal there. Where does it come from? Okay, so this is the terminal right here, and if I pull that wire out right here, that's the terminal for your power supply VAC1. So that wire is, I've got it coming way over to here. And let's go out and down. And so that wire, it goes under here and comes from the bottom of that breaker right there. You see that circuit breaker there? So down here where I'm pointing at is where the wire it comes from to feed that output card. If that's a circuit breaker feeding into the circuit breaker, it comes in from the main drop cord in my house here. So my house power is right there. It goes to a little breaker, a 3-amp breaker for protection, and then it goes from there to the PLC, to that output card, okay, to right up here. So that's where the power comes from, and that's the explanation of where this comes from. You got to physically land it there, and then from that point, all of your output devices are wired just like this. You leave output 0 on slot 2, and it goes to MCR coil A1, and then A2 goes to neutral. So let's trace that out. So output 0 in slot 2, it goes to the MCR coil. So output 0 is right here. It's in you have the left side and the right side of those terminal strips. So let me get my headlight on. Actually, I don't need the headlight. You got good lighting on that camera anyway. So here, output 0 is in the back row. So if you see right here, output 0, it's on the back row right here, my hand there. And if we trace that wire and we come down, then it comes down here to your MCR master control relay. That's your master control relay right there. And then let me stretch the camera again and come down. So this is the wire that came from output 0. You follow that? You see where it says, A1? Can you read that? It says A1?
Darwood.
Yeah.
I can't read it, but I'll take your word for it.
Darwood.
How about now? You see the A1? Yeah. What you got, Justin?
What was the authorization number for Darren? Did you send that through email?
The authorization number is what I gave you today. It's going to be the same for everybody. The authorization number, which hold on, I'll give it to you.
Oh, I got it. I wrote it down, didn't I?
Yeah, you did. 704-3525.
704-3525.
Yeah, that's the authorization number that'll link his account to the college. Now that's not a serial number, and that ain't a product key.
I know that. I got the serial number and stuff.
Yeah. Okay.
All right.
Now,
I'm good now. Appreciate it.
You're welcome. You see, this hot wire come from output 0, everybody. It goes to terminal A1. Y'all follow that? And then this says A2. The neutral wire leaves here. We went output 0 to A1 terminal on the MCR coil right here. This is the MCR, master control relay. That is the hot terminal for the coil. You put power on that, it makes it pull in like this. It pulls in. That's what makes it actually draw in when you put power on that leg right there. as long as you got a neutral hook right there. So here, your neutral is A2, and it goes out to your 0-volt AC neutral. So let's trace that out. How does it get to there? So let's go up. Now I've got the neutral for everything tied together going back to the main neutral. So if you watch closely here, I've got that neutral, and I have the neutral for the 3 starters. You have the contactor and the overload relay for motor starter 1, 2, and 3. Let's take a look at the neutral side of those, and you'll understand what I got going on right here. For each starter, like this is MCR, it doesn't have an overload relay. Motor starter 1 has an overload, motor starter 2 does, and motor starter 3 has an overload relays. Let's take a look at the neutral, how all that's tied together, so you'll understand what's going on there. So for the MCR, it has A2 neutral, and it goes to the main neutral bus. Okay, everybody there?
Yeah.
Okay. Now, look, for motor starter 1, when we leave output 1, which I'll trace it in a minute, when you leave output 1, you go to here to the A1 here. Then it leaves A2, and it goes through the overload relay down into here. So let's trace that. You go to the coil for motor starter 1, A1, and then you leave A2, and you got to go through the overload relay before you hit the real neutral there. So when you leave a motor starter that does have an overload relay, you leave A2 instead of going straight to neutral. You got to go through a protection contact that can pop open if something goes wrong. If the motor overloads, that'll pop open, it'll cut your neutral leg and it'll cut your starter off. So
in other words, the first one doesn't have that.
The first one doesn't have it because it's not for a motor. It's a master control for the whole machine.
Okay,
it's not controlling the motor directly. It's just it's a permission relay that lets the whole machine run.
Oh yeah, I remember.
Now we don't have it really tied in to really actually do that, but I'm just saying that that's what that will be for on a machine. If this was on a real machine, then the contacts that are controlled by that coil, those contacts, what they would do is they would actually be in control of all the power legs for everything in the system. So there would be a set of contacts coming off of that MCR, and what they would do is when they're engaged, it would allow power to enter. It would allow power to enter everything. It would actually be way ahead for the power, and it would actually allow power to get to everything in the system, or either not get power. So
okay. So
anyway, for each one of these starters, so you can understand about the neutral leg, since we're at this point right here, every one of the motor starter coils here, when you leave them on A2 for the neutral, they all go to a 95 on the overload, and then they leave 96 and go back to the main neutral. So let's just trace it on one of them. So for number 1 here, when you leave the A2 terminal, let's go over, let's see, like this. Now, okay, so you can see the schematic and the device at the same time. So this is pretty good. So for this is going to be for M1 motor starter. You come in from the PLC here, output 1 goes to A1, which it goes in right to here where I'm pointing at. That would be from the output of the PLC. And then the A2 terminal, which is here, it goes to 95 on the overload. So it goes from here, right? That little short wire goes to 95. That's 95 on your overload relay here. You might not be able to read it, but that's what that is, 95. And then you leave the overload on 96, and then you join the actual real neutral, the permanent neutral that's always neutral. So all of the 96s on the overload relays, all of them join together, and they all go back to the main neutral of my drop cord. So I'll just show you how the 96 is tied together. You leave the A2 and go to 95, and then all of the 96s are together. You see that? So all of the neutrals are together here. You have A2 on the MCR, And then you have 96, 96 together, 96 together here. All of the 96s are together. You see that? All of the 96s are together, and then they join with that A2, and then they go on back to the main neutral here. So there you go. A2, 96, 96, and then 96. This is where it leaves the overload relays. All of them, they leave, and they all join together here. And then that goes back here to a neutral bus, and that just goes back up to my drop cord. That just goes back up to the main drop cord up top. Does that make sense, what we got here as far as the neutrals? Am I putting y'all to sleep, or are y'all okay with that?
Yeah, it makes sense.
Yeah,
I remember doing that in motors and controls class.
Right, you did it in motor. I just wanted you to understand the wiring. Once we go over the wiring one time, then we're going to start running programs. But we got to go over the wiring because I can't teach a class without wiring, you know. And I wish you guys could physically do it, but for right now, you're not going to be able to right now. But if you see what's going on, then you would be prepared to actually do it yourself at your first opportunity. And then output 4, 5, and 6. Well, let's just say when you leave output 1, it goes to 1M. Output 2, 2M, and then output 3 goes to M3 rather. So 1, 2, and 3 goes to these right here. So let's take a quick look at that on the hot side of things. So let's go back up top, and these 3 hot wires for M1, M2, M3, we're going to find out where they come from just real quickly here. Go back up. So output 1, 2, and 3. Output 1. I'll just trace one of these so you can see where it's going. Okay, and I won't tie up your time with too much here. So output 1 is for motor starter M1. That 1 is sitting right here. Everybody see that? And let's just trace it on down that one wire, and it goes down where my hand is. You can see where it goes into the first one there. See it?
Oh yeah.
So it goes to A1 on the M1 starter, not MCR, but on M1. The other one for M2, let's just trace it backwards. Let's go backwards with it. That wire comes in, and it goes to output 2. Output 2 is the one back there on that back row. See it? So it's that one on the back. And then 3, if we go 3, hold on. 3 is the third one down. 1, 2, 3. Pull that out. So there goes output 3. You count on the label down 1, 2, 3 there, and then the third screw down there, and I'm pulling that wire. Bring the camera down, and there it goes right there to your third one. You see that? So it's going to your third one. Yeah.
Hey man, so I'm trying to. It won't let me download this thing on his computer. It says software requirements is Windows 8.1 Professional 64-bit with April 2014 update rollup.
Hold on. Do a screen share.
It's on Darren's computer.
Okay, so read it real slow again.
See, I get up here where I have to click on the program and then hit the under action, hit the download button.
Yeah.
And when I hit it, nothing's happening. I mean, I hit it and it won't do anything. And I hit the release notes thing to tell me exactly, to see where the requirements are for it. And it says software requirements, the Windows 10 Professional, Windows 7 Professional, Windows 8.1 Professional, and that's the only Windows 8 that's on here. And it says Windows 8.1 Professional 64-bit with April 2014 update rollup. But I mean, it's not. I mean, when I click on the I can click on the download button and it will not download it. I mean, click on it all day.
Look, can you take that computer and can you join this Zoom session and let me see that?
I don't know if this computer will do it. Probably blow up before I get that far.
Well, you said it was a newer computer, right?
It's 2013. Newer than mine.
It's pretty damn old.
Newer than mine. Mine's
See
right
if
after
you
the made laptop.
listen. See if you can connect with me on Zoom. Join the Zoom session on that computer, and when you get, then tell me when you're in. Let me look at that screen.
All right, I'm going to it.
Now, while you're working on that, I'm going to keep talking. Okay.
All right.
Now, so everybody, I don't want to bore everybody, but so we traced out the wiring on these starters. Everybody good with that? Is there any questions? Is there any questions about the wiring on these right here? If not, we're going to move on to the lights. The lights are output 4, 5, and 6, and they go to green, yellow, and red. So let's go that way, and then we're going to be done with the wiring, and then we're going to be ready to download and run. So there goes my lights right there. If some of you guys that took motor controls, I know I'm boring you to death right now, but everybody in the class has not had it. So we got to, for their sake, to make it real, we got to cover this. Okay. So I'm taking the lights off, and see behind here, I've got, for the lights, I had the neutrals all joined together. I got them daisy chained around. So I've got one neutral coming in here, and it jumps here to the X2 terminal on all of these. All of them called the X2, and X2 terminal. If you look on the diagram. So here, the neutrals are all X2, and they all go together back to the main neutral. Okay. And now the hots come from the PLC output 4, 5, and 6 go to green, yellow, red. Let's just trace that out. So here for green, if we come around and we trace that black wire, I trace that black wire around. So that's for green. And we come back up here to the PLC itself, and there goes green, and it's going, let's count those off. So I'm on the back row, 1, 2, 3. It's the third one on the left row, 1, 2, 3. So it's output 4. You see that? Everybody follow? It's the third one on the left row, 1, 2, 3. So it's output 4. Output 4 for green. Let's get our schematic. Output 4, data dot 4 goes to green, and then 5 is yellow. So let's go 5. 5 is over here. Let's go this way. 5 is over here, which is it's a 4 screw. 1, 2, 3, 4. It output 5.
All right, Durwood, I'm on one of his now.
Okay, hold on one second. Let's finish this up, and then we'll get right to you. So this is output 5 right here. Output 5. We come down into the panel. We come into here, and it goes right to there to the X1 terminal on that yellow light. That's the yellow light in the middle, and that terminal is X1. Okay. So here, yellow light, output 5 to X1 terminal on. X1 means hot, X2 means neutral. That's the terminal names that are actually stamped onto the terminals for the pilot lights. And then the red light is output 6. So let's just trace that out. So the red light, last one, red light here, it goes out, back up top, back around like that. And the red light is the last one on this row, which is output 6. Output 6 is the bottom one over here. It's 1, 2, 3. It's the 4th terminal on the left row. 1, 2, 3. It's the 4th terminal, and there it goes way back there on the back. And I'm wiggling that around. Right back there. You can see me moving it right there. Everybody see that?
Yep.
So from what we went over there, you have a power wire. You got the main power source hooked up to VAC VDC1. That power is a power source for this whole group. This output 0, 1, 2, 3, 4, 5, 6, and 7. So this module is actually split into 2 groups. Now, if you're going to start using output 8, 9, 10, 11, 12, 13, 14, and 15, If you use these outputs, you got to put power on VAC2. You see that? And that VAC2 terminal would actually power all the other 8 outputs. There's 16 outputs total. So that power leg is for these 8. This power leg is for these other 8 that I'm not using right now. Y'all follow that? Does that make sense?
Yeah, I got it.
Right. So that's the power. That's going to supply, if I had 8 outputs, I've actually got 7 that I'm using. I could actually do another one. It could go output 0 through 7 off of that one hot leg right there. And then internally in here, there's some relay contacts inside. You don't see them, but they're normally open. And when the PLC turns that on, it actually does this right here. It closes a little relay on each output. That there's literally relays in here. There's physical relays. They're really small ones. They're like in automotive. If you look under the hood of your car and pop up to some of those little control panels, you'll see some real small little relays, little ice cube relays. And there's little relays that are behind this in there in that module. That you see the word relay. It says relay right there. Those are 16 output relays. They are physical relays that are in there that that are used for this. And I can actually show you. We can take a second, and I believe I can actually show you what they look like. I think you can see it. Well, no, not on this one. You can't see it. I've seen some of them that you could actually see inside the panel, but you can't see it on this one. They got this covered up real well, so you're not going to be able to tell the relays in there, but they're little small little black relays that are in there. Okay. Thought I was going to show you something there on that, but that's okay. Sorry about that, the little delay there. Okay, so that takes care of the wiring there, and so we're gonna fold this up in here. And by the way, if you ever had, if this module here ever went bad, if that module went bad, you're not going to have to unwire everything. All you got to do is you loosen up the top screw and the bottom screw. You loosen those up, and that whole terminal block comes out. It's called a removable terminal block. It's a RTB. So if you look at what I'm doing here, you loosen that up right there, just real quick. Like if you had to change the module out, you loosen that up. Loosen that up, and the whole thing's going to come out. So you just loosen that up like that, and the whole thing comes out. See that? So at that point, then you would just. We're not right now. We're not going to go over replacing modules, but we're going to go over another date on how to physically slide that module out and disconnect it. There are some clips in the back here you got to undo. There's a data plug you got to undo, slide it that way to get the whole module out. But when you go to replace it, the wiring, you don't have to unwire anything. You just take the RTB out, the removable terminal block, get it out of the way, get this out of there by taking that little release right there and going over to the right, unclipping some DIN rail plugs in the back. We'll do that another night. This is not the right night for it. So we go back in here, press that in place. It snaps in, and you want to tighten these up a little bit at a time so that it doesn't get the terminal block in a bind. So do a couple of turns top, couple of turns bottom, and alternate, because you definitely don't want to get something like this in a bind and have it cock-sided in there, because you may break something. and that would not be good. It could cause a lot of damage on equipment by something in here going wrong. It could really cause you a lot of downtime and a lot of damage to equipment. So be real particular and careful when you're replacing things of this nature. So everything's in place here, and then we're going to take and we'll close this up and snap it in place. So we're ready to power it up now. Okay, so put the push button cover back on. Hold on, somebody's trying to call me. That'll have to wait. That's my cousin trying to call. So let's see. Get that out of there. Okay, so if you notice here, I don't have these other modules attached. I've got them disconnected. Y'all see that? I've got it on purpose so that when you configure your PLC, you got slot 1 and 2 only right now. Now later on another night, you're going to put a slot 3 and 4 in there for analog. And I've got them disconnected right now just so that you don't have too much to deal with. So let's go back. Now on the PLC itself, has for downloading a program into it. Let's talk about that. You got a USB port on the front that you would do initially if you've never set this PLC up. If you've never set up the Ethernet that's down in here, then you got to go in first through USB, download the program into here, and then go in through that USB connection to set the IP address of the IP ports that are down in here. So here, you got the Ethernet, the double Ethernet ports that are down in here, 1 and 2. These are not set up initially when you get a brand new unit, a brand new PLC out of the box. So we're going to start out by powering it up. We're going to go through USB first. I'm going to unplug Ethernet. I've got it unplugged, and we're going to pretend that this port has never been set up, that we have to go through this first in order to set an IP for this, okay? So that's our focus right there. And the cable that we're going to work with is this one. This is a standard USB-A that goes into the laptop and a USB-B that goes like into a printer. This is nothing more than a printer cable that you can get at Walmart. So it's nothing special about the cable to go to a PLC to do the initial setup through USB. It's that square one. It's called a B, and that's an A. All right, so we're going to go in through here first. It has a flat end and a rounded end, and the flat end goes to the left. So you want to go into there first, and that's the initial setup going through USB serial. And let's go up. Is everybody still with me? Am I boring you to death, or are you okay?
Oh yeah, we're still here.
Everybody's all right.
Just refreshing our memory.
All right, good. All right, so I got to close up the switch box here. Again, we're not gonna kill up time on wiring anymore. We did it one time, and that's enough, you know. So whoever didn't catch it can watch the recording. And so our focus is going to be on programming and testing with a meter, troubleshooting and writing logic and all that. So, okay, so USB only. Let's get the power on. Let me get my lockout out. And Justin, I didn't forget about you. We're going to get you squared away in just a second.
All right.
Be right with you, Justin.
Just.
Yeah.
Hey, tell Darren that my computer said it is 8.1 with Bing. The Bing is like Google or whatever that was built into it, but it was 64-bit.
It was 64-bit.
Yeah.
See, this one don't say nothing about no Bing. It just says 8.1. It just says 8.1, 64-bit.
Mine said 8.1 with Bing 64-bit.
Yeah, mine probably ain't gonna work then.
That's kind of what it's looking like. It's kind of doubtful that it would work. So you said you're online now?
Yeah, we're on here now.
Okay, hold on just a second.
I'm not.
Let's go.
I'm close.
All right. So can you do a screen share, Darren?
Hit that green button and hit share. And they can see everything you do on your computer. So don't give them no phone. You're unmuted, by the way. You're unmuted, by the way. That's on you.
Okay, you'll have to show us the screen that you're talking about for all I'm seeing. I'm seeing a Zoom screen right now.
Yeah, we're working on it. Hold on. Move. All right. That ain't right one. I'm on this screen here.
All right, go ahead.
See, I clicked it, and you hit download, and it's not downloading. It's not like it ain't doing anything at all.
Okay. Are you seeing any kind of pop-ups or anything at the bottom of the screen?
No. Probably push the fucking key to the board if you don't start.
So you never see anything beyond that?
No. You click on it and that's it.
I can't see the bottom of your screen because of my menu. But wave your mouse across the bottom and see, do you see anything? Does anything at all come up?
No, I mean there's nothing there. Slow down.
Have you already downloaded it?
No.
Wait a minute now. Hold on. It says selected items to download size 0.
Go back up.
Probably didn't.
Scroll back up. Something's not selected here.
Oh, I selected
The select description.
Yeah, you got it selected. I see that.
Looks like it blocked the download pop-up in the address bar at the top.
What are you doing there?
So your computer may have blocked the download.
What the hell? You can't have that shit. How you fix that?
Right click the little square in the address bar with the red dot in the bottom right corner of it.
Do who wasn't it? Scroll down.
In the
Go
address
up.
bar.
Now move over to the right.
That?
Yep. Right click that. Click on one of them blue links.
We can't have all this mess going on there. Shit everywhere.
There you go. Now you can download it. Scroll on down.
I want this thing.
We got an IT professional in the group, fellas.
What is this thing doing? I hit download.
Wait a minute.
I don't know what this is.
No. That's not what we're looking for there.
Go back. I ain't clicking on nothing. Hell, it won't let me go back. Get out there.
No.
Look at that.
That was not the right pop-up there. You got to get a different pop-up.
Scared of that.
So look, where the red thing was right there. see if you can, the second one I believe might be Rockwell. The second one is Rockwell.
We'll try that one then.
Sounds like a plan.
Now scroll down.
I want this computer free.
Now hit accept. Now do manage download. Now, again, Darren, I don't know. I honestly don't know if it's going to work or not, but if you want to kind of follow through with it and see, we can. I mean,
where I go to now, Durwood?
So, we're supposed to be seeing something pop up at the bottom left. See if there's another pop-up. Go back up to that red thing again.
Oh.
Hey, it's down there. If you look all the way at the bottom.
Oh yeah, I see it. Go down.
See the arrow?
Yeah.
The red arrow?
Get that shit off of there. Go over there.
Just X out that screen.
Yeah.
Where'd it go? Damn, it's way down there.
Yeah, it's all the way at the bottom. It's at your bottom.
How you get to that?
Expect us to get there.
Click on it.
Click on Internet Explorer.
That ain't it.
Yeah, that ain't it.
Go back.
Can't have that nonsense.
What it is, Durwood, he's got it somehow, for some reason, it's behind all his icons.
What the
his
hell?
toolbar.
Damn, wait a minute, I'll move it. Watch out. Yeah, you shouldn't tear it up with the fishes there. It don't work like that. Move. It don't work like that.
Can you see it yet, Durwood?
Yeah, I see. I see.
You see where his toolbar is? It's covering what it is.
Right there, but I can't get to there. There ain't far enough. I can't get there.
Can you close? Is there a way to close your toolbar?
That's what I'm working on.
No, I doubt it.
It's got.
Look, you can go to the bottom and right click and maybe hide or unlock the taskbar where it says lock. Unclick where it says lock.
There you go.
Uncheck it, and then it should float the taskbar maybe.
It lets you click on it.
You can't touch it while I touch it. It ain't gonna work. There's enough room. What has he done now?
So can you see it now?
No.
You're not able to get to it?
Nope, I can't get to it.
It's newer technology shit.
Can you listen
to the three dots under the X on your web browser? There's three dots going up and down. Click right there and then click downloads. It's that top one right there.
Just at the top.
Click on show in folder.
Show in folder.
Well, either way, he just ran it.
Right. Right. Kenneth, I tell you what, man, you are an IT guru, Bo. I didn't know that was in them three dots over there, man.
Been doing it a long time, boss man. It ain't nothing.
But I never took any IT classes. I took plenty of PLC classes, but they don't get into every little thing. You know, they don't get into every little thing with the IT world. You learn what you need to get by, but then like little things like that, I have never seen that. So Darren, you're gonna have to let it run that amount of time, and if you got it plugged in.
Yeah, it's plugged in.
Okay, so the best thing you can do is let it roll, and again, now Jamie's we never could get Jamie's going, but that's not to say that it may not be the same exact computer that he had.
Can't hurt to try it.
No, it won't hurt to try it.
It let me do all of this, but then when you go to download it on the computer and it starts to actually downloading it in the computer.
Installing.
Yeah, installing it. it would install and then it would stop and it'd pop up and say I didn't have this or didn't have that, and then
Yeah.
try to find that and download it, and eventually it
Yeah,
just
I think I was on that night. You needed to update your .NET framework through Windows Updater.
I don't know how to do that.
I didn't do this live in class.
But anyway, Darren, what you can do is this, man. When it gets down to when it gets complete, then you can let me know then, and then you can do a screen share if we're still on at that time. Okay.
All right, that'll work.
Now I'll be on. I can be on to say 11, 11:30, 12. It don't matter to me how long. I can be on here till say midnight. Okay.
Right.
I've actually got the session set up to where I actually set it up to midnight.
Okay.
That's not that you would want to, but if you did, I'm open. I'm game if you are. You know what I'm saying?
Yeah, I got you.
So I can do it if you want. If anybody wants to stay on that long, I'll help you that long. Okay.
Right.
So you let that thing roll, and you can cut your screen share back off real carefully.
Okay. Real carefully now. Cut it
Yeah,
off.
you don't touch nothing in that Rockwell box.
That's all you do. Don't touch nothing else.
All right, now. So now let's see. Let's X out of here. Let's go. So now we're gonna do the download through USB, and I'm gonna show you how that works. So I'm gonna do a screen share to show you RS links. We're getting another loud warning here. Flash flood warning.
Interrupt this.
That was a Viking wire.
Flash flood warning this area till 12:15 a.m. EDT. Avoid flooded areas.
Flash flood warning until 12:15 a.m. 12 a.m. Dylan Shook. Dylan has just emailed. Shook. The programs are downloading on my laptop, and I've been trying to move. Yeah.
Hey man, my laptop is froze the fuck up. I mean, it just won't let me do nothing. I can't touch it or nothing. I mean, it won't let me do anything. Can I restart it?
Yeah, it's not. Is it trying to install anything?
It's not trying to do anything. That's the problem.
You can't do it. You can't do a screen share.
I can't do anything. Like, I can't hear you on my laptop, and you're still working on. I don't know. I don't think I see your hand right now, and it's been like that for like 30 minutes.
You don't see nothing moving nothing moving in the webcam.
No, your hand's been there for 30 minutes.
All right.
I had to come out of Zoom earlier because that's what happened to me. My whole Zoom just froze up on me.
Yeah, well, I tried that and it's still not working. I hit end set or leave meeting, and it's your hand's still stuck there.
Earlier, I was having trouble with my internet and I couldn't see any video.
Okay, well, you were in the process of doing the install, right?
Yeah, I written it installed.
It was in the process of doing that, so it's okay if it's froze up. Are you saying that your mouse won't do anything?
No, nothing's doing anything. Ain't done nothing for 30 minutes.
Okay, so go ahead and reboot the computer, and then when you get back online with me, do a screen share, and I'll help you get it started again.
All right.
We'll have to actually trigger the setup again, or the DVD part 1. We'll have to trigger that again. So we've had to do that with other people. So that ain't nothing strange. Okay. So do y'all see my desktop there?
Yes, sir.
Yeah, I see it.
Okay. So we're gonna go into RS links right now. And we go over to the third icon for configure drivers. And now, if you notice right there, you've got the Ethernet driver running, which I'm going to stop it. Now it won't let me, I've actually got to cut off studio for it to let me do this. So let me do that for your sake. So I'm going to actually cut studio off. So that Links is not tied up right now. I go into Links Classic here. I go under Configure Drivers, and I'm going to cut the Ethernet driver off. I'm going to stop it and delete it. And then the virtual backplane driver, I'm actually going to just actually delete that too, that there's no drivers in my window. Do y'all see it's blank now?
Yeah.
And let me just show you something. Let me just show you something kind of neat here. Let's see. I got my I'm gonna go back to my webcam real quick. I'm gonna cut screen share off. And now I got my webcam back up where you can see it big. You need to see something here. I just want to just show you how the driver works. Hold on, I got to set the camera down. Now you see this. Y'all see that end of the cable right there. Everybody see that?
Yeah.
Yeah.
It's not plugged in.
USB.
I'm getting ready to plug it in to this adapter right here, but it ain't plugged in yet. First. So what I'm going to do is I'm going to go back to Links and let you see that as soon as I plug that in, the driver will automatically appear. You don't have to really pull it up out of the options. So I just want you to see that it ain't plugged in on the laptop yet. So I'm going to do screen share again. Now, do you see that blank screen there?
Yeah.
Now, you probably also see my camera, don't you? In a small window. Do y'all see that, my camera?
You can see it in a small window.
Right, now watch this. Now you watch the camera when I plug this cable in, and you also watch the screen that you're going to see a USB driver just appear just right out of the blue by itself. It's a plug and play driver. So here we go. I'm going to plug this in. Now here it goes. It's going to plug in. Now, did you see that driver show up?
Yeah.
So that driver showed up by itself. So I did not have to go in the available driver types. I did not have to go and pull it. You see that? It's actually running. So that's an important point there, is that when you go to connect with a PLC here in the webcam through the USB for the first time, it's a plug and play driver. Plug it in and that driver automatically, it sets itself up for this. Okay. So now the next step is going to be, if you look at the screen, is it's running, and we're just going to hit close. Now let's go up to RS Who on the screen and hit that. And now let's actually go in there and expand the USB driver. See that?
Yep.
Now, do you see what it sees there?
Yeah.
What does it say under USB? It says what? Kenneth McKelvin, Basic Logic Functions, Com Logic. So it actually sees the PLC.
Right.
Now, I previously downloaded it. Which I did that just to check his program. The only reason you're seeing his name was because I had already downloaded it, guys. I'm going to download it again for your sake. But what you would have saw would be, you would have saw the logic processor, the L24ER QB1B. You would have seen that without the name if I had not downloaded the program yet. Okay, but we're going to download the program again, so you'll see how the actual download is going to go. So now let me put the webcam back up on the stand. So here I am holding that. Okay, so now links is recognizing that port on the PLC. It does see it. I'm going to minimize links, and I'm going to open up Studio 5000. And I had already copied his file into my recent project, so I'm just going to pull it up. The ones that you're emailing me, I'm going to pull them up one at a time like this, and then download them in there. And it won't take but a minute to do it, because again, we're not going to trace wires out no more. We're done with that. Hold on, it says my screen sharing is paused. Let me hit stop share and then share again. Do y'all see my screen there?
Yeah.
Yes.
Yeah, I can see your mouse moving too.
Okay, so do you see his logic right there?
Yes, sir.
All right, now good. So now let's go under through communications and who active. And what do you see there? What does that say?
USB.
Right. So we're not going through Ethernet first. You got to get through USB first so you can set up the Ethernet port. So when you go to there and you click on the controller, the 1769 L24ER, that one, then it gives you option to download. So we're going to download through USB initially. And we're talking about a brand new PLC that has never been set up for Ethernet. Your IP address is going to be special for whatever plant that you're in. It's going to be unique. Okay, so right now, his program has been downloaded, and we're actually in run mode right now. Now we're going to test one app. Okay, well, hold on. Before we test the program, let's go ahead and set up the Ethernet port so that we can go through Ethernet and you see how that's done. Okay, so I'm going to go over here and stretch that over while I've got it on my mind. So again, we are through there, and if I hit one of the switches, you see one of the switches come on. I've got 1, 2, and 3 right there. You see the MCR come on? Y'all see that?
Yes, sir.
Yep.
Now let's cut them back off there. You see that we are online. His program's working. Now let's get set up with Ethernet and switch over to Ethernet so that's going to be the normal way you do it. So you go down to here to down to Ethernet. That's your Ethernet port right there. And you want to right click on it and hit properties of the Ethernet port. And that's just where you set up your addresses at. So originally, let's say for instance, if you came into here, instead of it saying manually configure IP settings, it may say obtain IP settings automatically through DHCP maybe. So when you first install the PLC, if it's a brand new one out of the box, you won't have any addresses in here. That 130, 130 stuff won't be in there. There won't be anything over here. And you're going to click manually configure the IP settings. And then you've got to go off of some information based on the plant that you're in, a list of IP addresses for the particular machine that you're working on. And I'm going to give you an example of that so that you'll know, have a rhyme or reason about why these numbers are like they are. So I'm going to pull up a document that's going to show you an example of what we have at school on an assembly line that has a bunch of different IP addresses for different PLCs. So we're going to minimize this and go here. Okay, now, so do y'all see that list of, do you see this list of IP addresses here?
Yeah.
Now, at the college, in our automation area, we have a SMC automation system, and it has 6 PLCs on 6 different stations. And some of you guys have already had the class. So for station 1, this is the IP address. Everything is 130 except the last section. It's a .1 through .6. So each PLC has to have a unique address, and the last portion of the address has to be something different. But the first 3 sections need to be the same. Now, the 130s were decided on by a company called SMC in Spain that built the educational system that we have. So the 130s and all that, that's up to the engineer that designs the system as to what he puts in there. So when you go to work in a plant, you need a cheat sheet like this that tells you what all the IPs are in the area that you're working in that plant, so that you know not to repeat some IP address and end up with an address conflict. So those 6 PLCs are 1 through 6 with 130s in front of them. That's what we have at the college. Each station also has a remote input-output unit that's behind each station. So for station 1, the remote I/O module behind the machine is a .13. Where the main PLC up front on the machine is a .1. So this is a separate module with a different Ethernet port that's behind the machine for other I/O behind the machine on where the conveyor belt is. And some of y'all know what we're talking about here, Connor and Cameron and Roger. Y'all know what we're dealing with. You've dealt with this.
Oh yeah.
So if you notice here, you have 1 through 6 and then 13 through 19. And then the laptops that the students use, like some of you guys, if you come in January to take this class, it's like an advanced PLC class. Then the laptops that you use also have to have IP addresses put in them. You got to manually put that in your laptop yourself. It has to be done manually. So on my laptop, mine is a .100. And then the student laptops, the 6 that the students use, is a 101 through a 106. And see, I decided on them numbers. I just chosen to start at 100 and go up. I didn't have to. I could have started at 20 and went up. But I said, I'm just going to start at even 100 and go up. And that's what we have for our laptops. So my laptop that I'm using right now here at the house, right now has got a .100 IP address that I put into it for this particular port, for this Ethernet port on my laptop. And then, so every device in the system has to have a unique IP address with 130s in the beginning of it. And the last section has to be something unique. Then you also have to have, you have to have an IP address like this, similar to this. And you've also got to have something called a subnet mask. The subnet mask has to be the same mask for every device in the network, including PLCs, remote I/O, and laptops. Have to have that same mask. So with that in mind there, we're going to go back. I'm going to minimize this and go back to links. Back to, let's see where we at. No, not links, but back to Studio. Hold on. I actually cut Studio off a while ago. I've got to cut it back on. Okay. So we've got to go back into Studio 5000. Let's open that back up. I had shut that off because, wait a minute. I still got it up. It's right down here. I'm sorry. It's just getting late. You see right there, the little gears down there. It was in the background. I had a brain freeze there, guys. Sorry about that. So this PLC here at my house, instead of me being in the 100, 101 and so on, I chose 200 for this one. Okay. Everybody follow? And then for the subnet mask, I made it to match what I already had. Now this can be way different wherever you work at. Say if you're at Hogslat or whatever plant you're working at, Goodyear or wherever you're at, you got to get this information here from whoever's in charge of your system. So like I just showed you that sheet, that stuff has to be shown to you by somebody like Ronnie Godwin or Travis or whoever's in charge. They got to share this information with you so that you're going to be exactly right on point with however you set it up. So if you manually configure them, you can go in and change these numbers. You see how that is right there? I'm going to go in and zero all this out. So do y'all see that there's nothing in there now?
Yeah.
Yeah.
So I'm going to go in, I'm going to hit the 130.130.130. And for this PLC here at the house, I just chosen another increment of say 200. And it's pretty much up to me. Uh-oh. And then on the subnet mask, it's going to be the 255, 255, 255, and then 0. Trying to explain what all these numbers mean would be like a whole session of its own, breaking that down into binary codes and what does a subnet mask mean. Just remember this, fellas, for right now. All you need to know is this. If you ain't got that mask on, you can't get into this party, okay? If you got so you can't get into group if you don't have that particular mask on. So that's kind of a crude way to say it. But you got to have a unique IP address, but you've got to have the same subnet mask. That mask is kind of like a filter in so many words that has to be exactly this for you to join the network. Everybody okay with that?
Yes, sir.
So now we're going to hit apply. Danger. Making the changing the parameters will interrupt connections to or from the controller, and you say yes. And so it accepted it, and I can hit OK. And if you want to double check that, you right click on the Ethernet port again and look at the properties, and you'll see that those changes are in there. Okay, everybody good with that? So now let's hit OK. And now I'm gonna hook up the Ethernet cable and disconnect the USB, and we're gonna make sure that we can actually communicate through Ethernet. Okay. So I'm gonna pull up links. I'm gonna pull up RS links, and let's see. Actually, I'm gonna choose to go offline so that I can cut that USB driver off. So I go offline. Now I'm not talking through the USB connector anymore. And I'm going to pull up links. I'm going to go in under configure drivers, and I'm going to shut that off. It's being used because Studio is actually up and running. So you can't stop it. No, can't stop it. Hit close. I think we can still run it with the Ethernet. We can go instead of me cutting Studio off again, and then it may let me cut it off. Then we'll try that. So let's go back to links. And now to set up an Ethernet driver, we're going to do this. We go under the third icon for configure drivers, and we hit configure drivers. Under available, we choose Ethernet IP. Everybody okay with that?
Yeah.
Sounds good to me.
Ethernet IP driver. The standard Ethernet driver is for panel views or touch screens. So if you're doing panel view plus, which is a touch screen, you use the plain Ethernet driver. If you're doing PLCs, you do the Ethernet IP driver. The IP means industrial protocol. So you go into there and you hit add new, and that's the default name for the driver, and I always leave it alone. You hit OK. Now we got to be careful here as to what connection point that we're going to go through. Now I happen to know that, hold on. Ethernet adapter 2 is my second Ethernet port coming out of the computer. I've got adapter 1. Adapter 1 is the one I have going, actually doing Zoom on. So I have 2 Ethernet ports coming out of the laptop. I got USB adapters that are going USB to Ethernet. So the Ethernet adapter 1 is on the internet right now doing Zoom. This one is the one that is used for the PLC. And hit apply and hit OK. And so that driver is actually running right now, and I can hit close. And now I can expand that driver and see, does it see the PLC? Well, actually I got to plug it in first. So if you look on my webcam here, I got the cable here. I'm going to plug the cable into the bottom port, the Ethernet port on the PLC now. So I'm going to move it down. So I'm getting ready to plug this in the bottom here. I go in with it like that. And so we're plugged in. And you're seeing a link 1 light up here on the PLC. So let's expand the driver on the screen now. And what do you see? The Ethernet driver on the screen sees that .200 address. You see that? Everybody see? Do y'all see the 130, 130, 130.200?
Yeah, I see it.
If I expand it, then you see the compact bus system, and then you see the embedded I/O, this called discrete or digital I/O, and then you see that output, that relay output module. So the Ethernet driver is actually seeing the physical PLC. It does see it. All right. So let's see if we can cut off the USB driver. Maybe now, maybe it'll let us do that. Out of there. Let's see if it'll let us cut it off now. It won't. It won't while Lynx is actually running. So what I can do very quickly here, is I'm going to shut Studio just for your sake. I want you to see that it is going nothing but Ethernet. I'm just gonna shut. Maybe I can. Yeah, I'm just gonna for ease of speed here. I'm going to cut that off. There were changes made, and I hit save. So I cut Studio off. Let's go back into Lynx here. Go under drivers here, and let's get rid of that USB driver. We'll hit stop and get rid of it. Now we have nothing but Ethernet. Can everybody see that?
Yeah.
Now, the only reason I went through all of that is to show you that we are going to be going through nothing but USB. I mean Ethernet. I'm sorry. So now you go through there, and it does see the address, so we're good to go there. I'm gonna minimize Lynx and pull Studio back up, and go back into his project. Go into main program, main routine. There goes his logic. We're going to go a little bigger here. Pull that down. Now we're going to go online through communications and who active, and now Ethernet instead of USB. So there goes the .200, and so it does see it. And now we've already downloaded. We've already done that. We're just going to go online. The program was already in there. We did that with USB. Okay, so we're actually online, and it's in remote run. So what I'm going to do is I'm going to actually go on these other outputs that we're not looking at the moment. And I'm going to right click and I'm going to hit force off. Forcing off is going to make sure that the physical outputs don't come on and start sort of confusing the situation here since we're sharing input. So I'm going to force that off. It's purple right now until we enable the forces. I'm going to force all the outputs off. I'm just going to, yeah, I'll force every one of them off. So go here, off. I'm right clicking and hitting force off. Right click, force off. And this one is not an issue because we're using push buttons here. So this is not going to try to come on until I tell it to come on. So I don't have to force that one. Now, do y'all see in the purple there where it says off?
Yes.
Now, so those forces that I put in there, I've installed forces, but they're not enabled yet. When they get enabled, they'll be red, and then they'll really be forced off. So if you look over here, you follow my mouse over here. Do you see my mouse where I'm going here where it says forces?
Yeah.
Everybody sees now under forces, you want to open that up there and go into IO forcing and hit enable all forces. And now it says, do you want to enable the forces? And I'm going to say, yeah. When I do, the purple will turn to red and the forces will actually be enabled. Well, it actually went to, it's not, it used to be red. It's actually an amber color now. So I guess in version 32, they changed it to a gold color, amber. So now this output physically is never going to come on until I remove that force. It's like having it locked out. So we're going to go here to the inputs, and I'm going to do 1, 2, 3, and then you'll see that come on. And then I'm going to show you the physical machine. So I'm going to go safety gate 1, safety gate 2, and now safety gate 3. You hear that clicking on? If I drop out 2, it drops out. If I drop out 1, it drops out. Okay, everybody see that?
Yep.
Yeah.
Now, I'm going to switch over to the webcam that you can see the machine. So I'm going to cut screen share off and go to full screen here. And I've got to reposition the camera so that you can see the whole thing here. Now, first of all,
It just kicked me out and I just got back in. So did it do anything?
now look, you see here for input 3. Now watch input 3 come on. You see that input 3? You see that?
Yeah.
That's 3. There goes 4. There goes 5. Now when I do all 3 of them, then you're going to see output 0 come on over here. So watch it. Let's do them one at a time. Input 3, and you don't have an output yet. Input 4. I'm sorry. Input 4. You got 2 of them. It's going to take, as soon as this one here comes on, that output's going to come on. Now watch it. 1, 2, 3. There, bam. See that? Then the output came on. So all 3 of those have to be on coming in voltage wise with 24 volts to get that output going to that MCR relay. So when you open up a panel, this is what you're going to see. You get LEDs as an easy way to troubleshoot without even getting on the computer. Okay. Now there's a lot of cases you do have to get on the computer, but you have individual lights for every input and for every output. So this is one of your first troubleshooting things that you go to is the lights. Let's back it out now. Now I've got the position. Let's see. I got to go way up. And let's see, how did I do that earlier? I had everything in view in one shot there. I think I had to go way up high. something like that. I'll be glad to get that other camera. I hope it's going to be a better deal. So now down here, can y'all see that red going in and out?
Yeah, I can.
Okay, so this is the MCR relay right here. Let me get the USB out of there. I got that USB. I don't even need that in there now. That out of the way. So now you can see the MCR relay. You can see the safety gate switches here. I've got these. They're simulated safety gates, and then you see this. So this is the PLC itself. So I'm going to cut these off. Now up here up top, when I do number 1, watch the light come on. It's good, fuzzy looking, but you'll see it. Number 1, you see that? And you don't get no MCR yet. It's not coming on. Now, how about number 2? See that? So you're watching me hit the switches, and you're seeing, y'all see the lights and me doing the switches?
Yes, sir.
Okay, that's safety gate number 2. Now on the machine, it would be a door closing a switch. Now, when I hit number 3 down here, you're going to see another LED, and then you're going to see that red plunger on that MCR kick in. You ready? 1, 2, 3. Bam, there it went. So that's what made it. That third one gave you that output up there, and it gave you the physical device pulling in. You see it? Now, if you're running and all the gates are closed and then the machine jams up and the guy doesn't cut the machine off, he just goes in there and opens up door 2. Then that drops out. You see it? And up top here, you've lost your LED in the middle. You've lost that LED. So you can do a fair amount of troubleshooting, just nothing but LEDs, if you know the program well enough. If you know the logic in the program, then you can actually use LEDs in a lot of cases in a meter and troubleshoot. And you don't always have to have the computer out to troubleshoot, but you have to know what the logic is, because look, the wiring of it doesn't tell you what the logic is. You know, these switches are not wired in series, are they? See, would you say that they're wired in series or not?
You wouldn't really know till you looked at the logic.
They're not. Listen, they're not wired in series. Nothing's wired in series with PLCs, as far as, except out in here. You got a coil and an overload in series out here. But look, the relationship between these switches and the output is unknown until you get into program. So with PLCs, you get every field device like buttons and limit switches and all of those have dedicated inputs so that they can have separate lights like this up here, and you can actually troubleshoot them individually with lights, and that you can go into program and you can actually make the relationship to these and outputs be what you want them to in the program, and you don't have to really wire things in you don't have to wire logic anymore. In motor controls, we had to wire logic. You had to physically wire these in series if you were going to get series. But now, every field device has a dedicated input to itself with an LED and an address. And then the way that they connect together logically is completely done in software. And that's the beauty of PLCs, is you can go in there, you're using the same inputs for AND logic and OR logic and then combination, and you didn't have to change any wiring, right? Did y'all notice that? You didn't have to change any wiring to get all of those 7 functions. You actually just shared those inputs in your program, okay? So let's go down to the next line and see how the logic worked out. So I'm going to cut this off, and I'm going to go back to screen share again. And So I'm gonna force off the one that we just tested. I'm gonna force that one off by right clicking and hitting force off. And now the one on for OR logic, I'm gonna say remove the force. If I right click, now I don't want to force it on. I want to actually just remove the force. Now the difference between it is this. Removing a force is like this. It's like I take my hands completely off of this output and I'm not going to manipulate the output at all if I remove the force. Now, if I force on, guess what's going to happen? It's going to be forced on and it's going to stay on indefinitely, no matter what the PLC wants to do and the logic wants to do ahead of it. It's always going to stay on until you remove that force.
Or safety precautions too.
Say it again.
And also, if like there's safety precautions, it'll just still go on.
Right. Exactly. That's a good point, Roger. Roger knows this from school, that if you force the output on, like I force it on right now, it forced it on. Okay, it forced it on, and that starter pulled in with no conditions ahead of it. Right now, that physical device is on out there, and nothing is ahead of it to tell it to come on. It's going to stay on forever. Even if you have the safety gates open, when you force something on, it's going to come on. Even if somebody's in the machine and got their hands in it, it's going to come on. So don't ever use a force function unless people have got their hands out of the machine, because whatever you force on, if it happens to be a hydraulic cylinder or a cutter or whatever it happens to be, when you force it on, it's gonna come on, and it's not going to be looking at somebody in there. It's just going to come on whenever you say go. So you got to do it very careful. Forcing on is only used for troubleshooting purposes. So I'm gonna say remove the force. Now I took my hands completely off of that. So now you see the OR logic there. Does everybody see the OR logic?
Yeah.
Yeah.
So now I'm going to hit safety gate 1. You see it? So it came on just with 1, and then 2 will also do it. And then 3 will also do it by itself. Now let's switch over to the webcam. Okay. And now, do y'all see the bottom down there? So you're looking at this one right here. Motor starter 1. You're going to be looking for that one. Now watch. I'm going to cut on number 1 here. You see it pull in? Y'all see that?
Yeah.
Yeah.
How about number 2? Do y'all hear it clicking?
Yeah.
And then number 3. Now, let's look up top where the lights are. Up top, when I do number 1, you got that light I'm pointing at with the pencil. You got input 3, and it gives you the output. You see it? If I take it away, it's gone. It only takes 1 input to give you that output. See it? Now, how about the input 4? There it goes. 1 input is giving you that output now. It's giving you that starter. And then we go to the third one. Look at your LED up top. That one input is giving you that output. So you see your input and output LEDs there, how they're doing. And then you see down here that the starter's kicking in and out. So does that help you to see it on the real machine?
Yeah.
All right, now let's go to the next set of logic. So that gives you the OR. So let's go back to screen share. As soon as we finish this one, then I'm going to start downloading everybody else's program that has one that's still with me. And let's see.
I gotta get up in the morning, so.
Right. If you need to go, that's fine. I understand completely. So here you got combination logic here. So now I'm going to go to to starter 1, and I'm gonna force it off. And now I'm gonna remove the force for this one so that we can see it work. So I took my hands off of this one, and then we're gonna see it function. So we're gonna do safety limit switch 1. And then you can also do number, the other one, 4. Here. Oh, I'm sorry. Right there. You see, now with those, that's not enough to make it run, is it? You got to have the third one on, okay? So you got the or there, but it can't get through the and. It has to be and. This one or this one and that one. So I'm gonna cut that off and now do the third one. So now you got it. Or I can shut 1 off and cut 2 on, and you'll see that drop out and come right back. So let's cut 1 off. Cut 1 off and cut 2 back on. So now your power's running from here down this way, branching around and coming around this way through your and then your starter's coming on. Everybody got that?
Yeah.
So you could have, you could have 2 door switches in the thermostat, or whatever devices that you want to have with an and or with a combination. Now let's go to the camera and let's look at the actual devices here. So now we're going to be dealing with motor starter 2 here in the middle. Okay. So it's going to be this third one here. And I've got up here up top, I've got input 3 coming on. Oh, let's go back up. Input 3 is on. It can be 3 or 4 and 5. So let's do 5. So you see there? So I've got 3 and 5 are on right now. And then you're getting your output. You see it? You'll see that red thing going in and out?
Yeah.
So that's your logic right there. Now let's try it. Let's shut off let's shut 1 off and shut 2 on. So now we've got input 4 and 5. So it takes 4 and 5 right there to give you that output. So it's this one or this one and that one. Now the amazing thing is that we didn't have to change no wiring, did we?
I don't believe so.
We didn't wire anything different. The thing about PLCs, y'all just remember this, that however you wire them, every field device has a dedicated input, and every field device on outputs has a dedicated output. And it may have extra things tied to it for safeties, but you never wire buttons to coils anymore. You program a button to a coil, or you program a limit switch to a coil in the software. And so the wiring is very simple with PLCs, very simple. Everything has straight lines coming in individual and straight lines leaving going to your devices. And you don't ever wire logic anymore like you did in motor controls. In motor controls, the way things are done most of the time in plants is you actually marry a PLC to a motor control, and then you do your logic wire, you do your logic connections inside the PLC. Now, are all machines run on PLCs? Not all of them, but most of them are. There are some machines at Butterball and Smithfield Packing that don't have PLC, that they're all hardwired, physical wired devices that have buttons wired straight to these starters and lights, and there's no PLC involved. So you still need to know motor control wiring, because everything is not going to have a PLC. But I'd say, 95% of what's out there is going to have a PLC of some kind. Okay. So now let's move on to the next logic. And I know if you need to exit out, that's fine. I mean, honestly, it is. I wanted to finish up on Kenneth and then kind of see where we were on who.
All righty, Durwood. I'm going to go ahead and get off.
Okay, I understand completely. I honestly do.
Nah.
Yeah. So you have a good night, and we'll see you Tuesday, okay? And hey, listen, let me show you something before you get out of here. Here's what you can work on for the weekend, guys. Let me stop right now. I wish I'd told everybody this. I'm going to minimize this and go up to here. We have let's see, let's go exit full screen. If I go back to now I'm going. Do y'all see my Moodle page or not?
You got your webcam.
No.
I got the webcam on. All right. Let me go back to screen share. How about now? Do you see Moodle now? It says I've timed out. That ain't good. My main SCC login has changed from what that was. Let me go back out. I don't like that. Because I don't want the session to actually stop.
Probably just go back to the Sampson Community College homepage and just.
That's what I'm going to have to do. I've got to go back in there because the Moodle password does not. If you go straight into Moodle, it doesn't change with your main single sign-on.
Yeah.
It's still old, and I don't even remember what it was, to tell you the truth, without looking up in my wallet here. So let's go here.
So was it that other assignment that you want us to work on?
Yeah, just hold on. Let me. I wanted to show you the assignments that I have lined up that y'all could be working on, because I haven't even talked to you about chapter 1. I've got chapter 1 in there. I've got a worksheet you can be doing.
Said that for me, it said login failed due to inactivity.
All right, now, so do y'all see my Moodle page now with the welcome mat?
Yeah.
Yes, sir.
So we'll go on down here now, and here's what you can be working on the weekend. Is we have chapter 1 worksheet. Now I have, if you don't have your textbook, I've got chapter 1 textbook right here. So if you double click there, it's going to pull up the actual book copy. So there, this is the actual textbook. So I'm going to continue to run copies of it for folks that don't have the book yet. And you can go through there and you read chapter 1. And I'm going to cover some things in there. I'll talk about it Tuesday. But that's your chapter 1 right there, okay? There's a lot in there. Read it very slow. There's a lot in there. Now, so if I close this up, now look. So there goes the book copy. You can, I will download and save it to your laptop so you can have it, or to your phone. This is the actual worksheet itself. So you go through there and it says list the main 4 components. Do y'all see that? The questions?
Yes, sir.
List the main 4 main components of a programmable logic controller. And I'm giving you page references. See page 2 and 3 in the book, which should be that PDF that I have out there posted for you. So you're going to name those 4 in that block. All of these are essay type questions. It's not matching. I didn't have time to create a bunch of matching stuff that you just click on. You have to go in the book to get the information, and you're going to just manually write all that in there. And then
when you say just give a short answer.
Right. Yeah, exactly. But get it out of the book. Whatever you do, don't do like some people. Don't don't go to Google and get an answer for Google for everything, because believe me, I'll know on some of this stuff if you got it out of the book or not, because Google has a way of giving some goofy answers on some things. And believe me, I got some students that even though they've owned a book and had a book, and I knew they had one of them in front of them, instead of them reading the book, they wanted to get on that phone and Google the answer. They didn't want to read the book. They wanted to Google everything. So, you know, that's why I take time to actual scan the book chapter for you. But define the term interface, page 3. I tell you what page it's on. So you write the book answer for interface. What is interface in PLC terms? Because it doesn't mean the same thing in everything, but for PLCs, it's particular. And then define the word, the term real world, page 6 and 7. So I'm giving you page references for everything.
Thank you.
Okay. You go through and you answer all those questions, and there's a lot of stuff in there, giving definitions for acronyms and all. Go through and answer all that stuff and hit submit. So that's something you can be working on. Okay. So now let's go back to the Zoom. Hold on, let's go back to here. Go back to here. I'm gonna stop screen share. Okay, so we want to go to your next logic circuit. Let me get my head together here.
I'm going. Let's see.
Back to there. Okay. So your next one, Kenneth, was the not logic for the refrigerator door. Now this is a good one right here. So let's go force that off. And we're going to take the force off of this one. Now, so here, now this is one I want you to see very good here, that when there's no input coming in on input 3 and there's no voltage coming in, this instruction is actually satisfied. When there's no voltage coming in, there's no power coming in on 3, that's made and that green light's on. Now, I want you to see that there really is no voltage coming in here. This is actually an examine off instruction. What it takes to make it true and to make it illuminated is no voltage on the input 3. If there's no voltage coming in, this is going to be true. Now, let me switch over to the camera. Now watch closely here, don't miss this. You see that green light on right there? This switch is not on. Now I'm gonna cut the switch on and the light goes out. You see it?
Yes, sir.
Now watch up top. Input 3 is not on, but now it is. You see it? You see where my pencil's pointing at?
Yes, sir.
Now when I cut input 3 on, and it's on, you lose the output. Which is like saying with this switch over here that the refrigerator door is open now and I have no voltage coming in. The actual door is open. Input 3 is not on. Now with my hand here, I'm going to close the refrigerator door. Bam. When I do that, you get voltage coming in and it's shutting the light off in the refrigerator. You see that? In the program, we have a normally closed or an examine off instruction in the program, so that when you get voltage coming in, it's going to actually disrupt the circuit. So it does the opposite of a normally open. Does everybody see that?
Yes, sir.
So you just realize that even though this is a normally open contact here, the instruction that's in your program looks like normally closed. And what it wants to see is this. It wants to see no voltage coming in here, none, and it doesn't see any right now. So that instruction in your program is actually illuminated to true right now with the refrigerator door open right now. No voltage coming in. You get the refrigerator door light is on. Okay. Now, if I close the door, bam, then you get the input triggers. And when you trigger the input with 24 volts, it makes the instruction open up. It makes the instruction pop open instead of being closed. It makes it do the opposite. So that's an examine off instruction. It works the opposite of examine on. So when you get voltage coming into the input, then you lose the output. Okay. Now I can show you with a meter. And this is just very simple to show you here. If I take the meter here and I go to volts, that particular input is down here on the terminal strip. I'm going to go to common with my black probe, DC common, and then I'm going to go to input 3 there. So I'm looking at input 3 there, and you see what I got, 24 volts with the switch on. I cut the switch off. Hold on. What am I measuring here? Something's off here. Oh, I'm actually checking the stop button. Look. The stop button over here. I wasn't on the right input, guys. I'm sorry. The stop button over here. Look, when I press the stop button, look, the stop button in the bottom left over here, that's actually input 0. I was on the wrong one. See there? That red button in the bottom left, when I press it, you lose input 0. When I let go of it, you get it. That's the normally closed out here on that red button. That's what I was actually looking at right there. I was on the wrong one. The inputs are 0, 1, 0, 1, and then I think we skipped 2 and we went 3, 4, 5. So it's input 0 and 1 and then 3, 4, 5. So input 3 is over here. So I'm going to go to DC common here, and then 0 and 1 and then input 3. So it's right here. I had the wrong one. It's getting kind of late here. And I don't have the terminal strips actually labeled down there. I don't have numbers on them. So now watch the meter here. And I'm gonna turn on input 3. So with the switch on, you're getting 24 volts. Y'all see that? Turn the switch off, you get nothing. Turn the switch on, you're getting 24 volts coming in. The light comes on, and then the logic turns the output off. Do y'all see that? The correlation between that?
Yes, sir.
So here's what agrees. When I cut the input on, I see 24 volt. The input's on up here. So that light and the voltmeter do agree, okay? Voltage coming in agrees with that light. That light agrees with this. But the reason why the output doesn't come on, the reason why it goes off, is because of the instruction that we're using. We're using an examine off, which says that if you get an input, you're going to pop it open and cut that off. Y'all see that?
Yes, sir.
So that not logic means it's going to be the opposite of what the light says. If you get voltage coming in, the output's going to be the opposite of what that light says up here coming in, because of the instruction that you're using. Okay. So On the other hand, if you go back and you look at the AND logic, let's go back real quick here and watch this. If you go back to the top of the screen up there for his AND logic, just briefly here, and I'll remove that for us. Now, you watch what happens here. I'm going to show you an input. Now, you got all three of those right there. All three of those are on that top line there. Now, I'm going to just show you the voltmeter view of it. Is now we're looking at AND logic. Now, you got all three of those. And let's take a look with a meter what we're dealing with here. So if I go from common to input 3, right there, then I've got the 24 volts. You see that? Now, so I've got 24. This one here's on. I got 24 volts. I've got the lights on, and I've got the MCRs on down here. Now watch. If I cut it off, you lose it. So focus on the MCR down here. You see that? Kicks in, kicks off. It kicks in when you get the input. So when you get the input, the 24 volt coming in to input 3, that logic is using those normally opens in there or your examine on instructions. So when you get voltage coming in, then you get an output. You see that? So those instructions are like normally open contacts. So when you get an input, you get the voltage, you get the LED coming in, all three of them are on, then you get the physical output. This logic is not opposite like not logic is. This logic is just straightforward, to where you do have to have three inputs, all three inputs on, and then you get an output and you get that. So, you know, the inputs will agree with the output. When you get enough inputs on for that rung, then you're going to get your output. You follow?
Yeah.
If you go over and check the next one, then this is going to be for the middle switch here. So here, this is going to be for this input. You've got 24 volts coming in. Now watch. Now you don't. You see it? So it's gone. Now it's there. And now it's gone. I'm actually checking input 4 now. So when I cut it on, you're getting 24, and you're also getting that light in there, and you're also getting your output down here. You see that? Okay. So that in a nutshell is the basics of measuring the inputs. Let's check the rest of his logic. And I know it is getting really late. I don't want to hold you up.
Yeah, I'm getting right heavy-headed sitting
Yeah,
here.
yeah, me too. Yeah, it's been a long evening. So let's cut off.
Yeah, me too. And I still got to drive home.
My septic tank fell in today, so it's been a long one.
Yeah. Okay. I'll force that off. And so so we checked that one. Go here, and this is one we hadn't checked. We're going to check the NOR logic now. So here, if on the NOR logic right now, I don't have any inputs on. I've got the inputs released. So input 4 and 5 are not on right now, which means that they're made. There's no voltage coming in on 4 and 5. So I've got a yellow light out there. Okay. And so now we switch over to the webcam. And if you take a look here, you have input 4 and 5 here, I believe is what he was using. So here, if you do either one of those, you're going to lose that yellow light over there. So I'm going to do this one. You see it, you've lost it. Or if you do 5, you lose it. Y'all see that?
Yes, sir.
Now, so look, if you look at your inputs up here, this is reverse logic or not logic. So look, this input 4 here, you don't have it up here. You see that? Now you do. You see that light up top coming on? When you put voltage in there, you're actually breaking that one instruction and you're losing that yellow light. Now, if I release that switch and I go and I actually break this one, well, I'm sorry. If I make this one right here going in, I put voltage going in here, then you get the opposite logic on the output. See it, when this comes in, you lose the output. When you lose the input, you get the output. So that's where you have not logic in there. And with this one, you have two of them in series. It says that if I actually trigger either one of them and pop them open, then I lose the output, either one of them. They both have to be released in the program with no voltage coming in to get that output. Does that make sense?
No, yeah.
All right. Let's see. Go back. Now, so we'll force that one off and then remove this one. Now, this is the one that's like for your driver door and then your passenger door on the vehicle. So with this one, if I shut the driver door, I'm sorry, that was the passenger door. If I did that, you still have the light on. The interior light's still on. Now, if I shut the other one, hold on, data 5, data 3. Wait a minute, what's going on here? That's data 3, data 5. So here, if I actually close both of them, if I close both of the doors, then you lose the output. You lose the light inside the vehicle, which with both doors shut. All right, now let's go to the camera. And now you have, so here he has let's go back here. The top one is going to be the driver door, and there goes the passenger door, top and bottom there. But you got your interior light, that red light's on right now with both doors open. That's your doors. Now I'm going to close the driver door, and you still have your red light on. You see it? Now I close the passenger door, and you lose the light. So you had to actually trigger both of these and shut both of those doors to lose that light. Now take a look up here at the LEDs up top again. Now there's no inputs up here, right? But when I bring one input in, you get a light here, but you still get your output over here because it takes both of them. Now if I trigger this one and bring voltage in, then I've got 3 and 5 on in here coming in, and you've lost it. So that's like shutting both doors on a vehicle, and then you lose your interior light. So that's, everybody okay with that?
Oh yeah.
Okay.
Oh yeah, I got it.
Good. Okay. What you're looking at is the basis of all logic. I mean, if you don't lay this foundation down here, it's not, then larger things are certainly not going to make sense. But by you getting this, everything is going to make sense that you learn from here on out, if that makes sense. You're getting the foundation, which is going to mean you're going to have a good future in this stuff. So the last one is your memory logic. Now this is different here. When I hit the start button, you're going to see the coil come on, and then it'll make the holding come on real quick. And then when I let go of that, it's just going to stay running around here like a memory circuit. So here we go. I'm going to press start. 1, 2, 3, go. I do that, and then I let go. So momentarily pressing this and letting go gives you the output, which triggers the holding, and then you're running around here. And it's going to stay forever until you hit stop. Now, if I break this momentarily like that and then let go, then I have to actually reinitiate it with another start command to get it to go again. So I'm going to hit start, 1, 2, 3, go, start, and let go. And then you have, this is the way industrial motor controls work, is you use holding circuits with them, okay? So let's go to the physical machine. And we're dealing with the one over here with this starter over here. I'm going to hit stop. Do you see that kicking in, that red button there?
Yeah, I see.
Okay. Now, one important key about the stop button. This is a key right here. Physically, this red button is normally closed. It's a normally closed device. So in the diagram, it's a spring-loaded button that's already closed until I press it. When I press it, then you lose the input. But when I release it, you get input 0. Now watch this. You see input 0 up here at the top? That right there where I'm pointing at. When I press the button, once you're going to lose it. You see it? Y'all see that go away?
Yeah.
Where I'm pointing at.
Yep.
When I press the button, you lose it. Now that's how normally closed works. Normally closed means when I let go of it, normally it's actually closed and made. So I get voltage coming in to that input when I don't touch the button. When I touch the button, I lose the input. Now the start button is normally open. It's the next input. Now when I release it, I have nothing. But when I press it, look what happens. I get it. You see it? So it's the next one. That's the input for the start button. So it's normally open wired. It's not connected until I press it, and then I get the voltage coming in. So that's the important thing for you to know about normally closed when it's a physical button like that, is that when you let go of it, you get voltage coming in. Now, with that in mind there, right now I have voltage coming in with the red button released. So let's take a look at the logic and realize why we had to use an examine on with a normally closed button. Okay, that's what some people would kind of might got hung up on. It's normally closed. It's made right now coming in. It's made. Let's take a look at the logic.
Mr. King, I got to call it a night.
Okay, all right. Okay, your logic works good, and y'all have a good one. I didn't mean to hold you up so long. And y'all have a good weekend. And sorry to hold you so long. I'm like a long-winded preacher. I just go on and on, man.
Ain't nothing wrong with it. I like learning.
Yep. And I'm looking at that. You've only got like 10 more sessions in this class. I kind of if anybody wants to stay on and me help them, I will, because I kind of know how short the class is and all that. So anyway.
Y'all have a good night.
You too, Kenneth, and you did a good job on your logic. Very good. Thank you. Yeah.
Well, I'll probably do this weekend. They're going to try and fix my internet this weekend.
Uh-huh.
Matter of fact, the guy's coming tomorrow because he ran it too remotely. And he says, man, there's something wrong with your stuff. He said, you ain't pulling what you should be pulling. I said, I know. That's what I've been trying to tell you guys.
Who told you that?
The company I go through, the satellite company. See, I got to do satellite where I live. So it's Viasat. It's like HughesNet.
And so they're going to come out the weekend and they're going to look at it.
They're supposed to be out there tomorrow.
Good. I'm glad, man.
Yeah, me too. Because this traveling back and forth is tiring.
Yeah. Okay. Well, you have a good weekend. Have a safe trip home.
All right, you too. And probably this weekend, if he does get it right, I'll probably do a Zoom at the house and see how it runs with you.
That'll work. Yeah. If you do a speed test, you'll know right off of the bat.
Right. I think you said we got to have an upload on 1, right?
At least a minimum of 1, and if you could get around 3 or better, that's good. Mine's around 3 upload, and it's as you can tell, it does pretty good.
Okay. He said that's what he wants to try to get it to anyways, a 3. That's what we should be running out there.
Oh, they told you that?
Yeah, that's why he said something's not right. Well, I guess when they originally put my satellite in, what they might have done, whoever did it, they might not have, because what it does, it keeps saying 1 minute the satellite's not hitting right, and then another minute, and then it says the modem's not reading the satellite. So there's something in there in between that's not connected right.
Right, and they may have to actually repoint the dish a little bit or something too, you know.
Yeah, that's what he's going to do tomorrow morning. He's going to come out there and just run the whole system and recheck everything.
Right, I bet you'll be good to go, and you won't have to sit out there in the parking lot like that.
Yeah. I sure appreciate what you guys done, you and Ronnie.
Yeah, you're welcome. Believe me, it's time well spent by you being willing to do this, Eric. It's going to pay off for you, man. It really is. I just know it will. I mean, every ounce of effort you put into this stuff is going to pay you back. So it's never in vain, never, ever. Every ounce of your work is going to pay off well for you. So.
Oh yeah, I truly believe that.
It will.
Okay.
Okay.
All right, Durwood, you have a good night, man.
Thank you. You too. God bless you, man.
You too.